Hi everybody. Good morning, my dear students. Please just confirm once, is the audio and video clear? And welcome to this marathon class. Right, just quickly confirm if everybody can see me and hear me properly so that we will very quickly start with the class. Okay, great, amazing. Lakshmi Deepa says video is not coming. All clear? All right. Lakshmi Deepa beta, but there could be some issue at your end. Just maybe refresh once, right? Okay, students. So very warm welcome to everybody to this second day of the Marathon Gold session. And the chapters which we have picked up for today are: number 1, some basic concepts of chemistry. Number 2, atomic structure. Number 3, we'll be talking about thermodynamics. Number 4, equilibrium, which will consist of both chemical as well as ionic. And finally, number 5, redox reactions. So without wasting any time, guys, let us quickly begin with our class. The intention of the class would be to attack the most probable areas which you can come across while appearing for your NEET 2026 exam. Right, so we begin with the first chapter, everybody. The name of the chapter is Some Basic Concepts of Chemistry. What you should keep ready before the class is your NCERT. You should keep with you, and along with that you can keep a notebook and a pen, pencil, whatever you prefer to write, because we'll be practicing some of the solved examples. As we all know that this is the physical chemistry portion, right? So it involves some numerical solving as well, everyone. So therefore, please keep the pen and pencil or paper, copy and pencil or paper, I mean pencil or pen, sorry, pencil or pen, whatever you are comfortable with. Right, everybody. So we begin with some basic concepts of chemistry. Some of the important points I have highlighted, like this first one, the first 2-3 pages are not that important. This question, the drug AZT, azidothiamidine, why have I highlighted it? Just now in the IP exams this came. Okay, what is it used for? So it is used for helping AIDS patients. So just remember this name, AZT is used for helping out the AIDS patients, and this came in the IP, just in case you get lucky. Right, moving forward, classification of matter and all, very simple thing everybody knows. Okay, so matter consists of mixtures and pure substances. And mixtures can be homogeneous, heterogeneous. Pure substances can be elements or compounds. This is very elementary stuff. So I hope everybody has very clear-cut idea about this. Moving ahead, over here you won't find anything too relevant. Maybe the 7 fundamental units. You can have a look at their symbols and their the basic fundamental quantity and its unit. Very basic stuff, 9th, 10th level stuff. Everybody knows about this. This table I would definitely recommend you to spend some time with. Okay, you should know over here, particularly the important abbreviations and their multiples, beta, and their multiples, right? So some of the important ones like femto is there. So femto later on in atomic structure it will come as well. Okay, so femto is beta 10 to the power minus 15. Then after this you have some important ones like nano, micro. So just make sure that you are definitely going through this table. Okay, little bit idea you should have. Pico is there, nano is there. So these are some abbreviations. I would not say that just mug it all up, but yes, definitely spend some time with it so that you are not completely blank. Like giga comes, mega comes. So mega is 10 to the power 6. It comes in the case of frequency. Then after that, for very small lengths, nano comes minus 9 meter, micro comes minus 6 meters in case of micrometer. For length, one particular unit is also used, angstrom. So all this is going to come in the next chapter of atomic structure. So very quickly, moving ahead, let's come to the important portion now. So we'll straight away come to the first solved example. Acha, before that, one chinna thing over here, the difference between precision and accuracy. One small thing, the difference between precision and accuracy, beta, right? In exemplar also there is a first or second question only in the NCERT exemplar of this topic. So you should know the difference between precision and accuracy. And this example, my dear kids, is sufficient to explain this. Exactly the same table is given in your exemplar as well, right? So what do you understand by precision? Precision means that the data which you are doing any experiment, you are measuring some value. What do we do in an experiment, guys? In an experiment, we measure the values, right? We record something, we measure something. So if the data are close enough to each other, the 2 readings, 3 readings, whatever readings you have taken, if they are close enough, they are said to be precise. And if they are close to the actual value, then they are said to be accurate. Precision refers to closeness of the various measurements. Please focus on this. Closeness of the various measurements, and accuracy is the agreement of a particular value to the true value. So you should know the difference between precision and accuracy, right? And this table offers you a very clear-cut example. 3 students are there, alpha, beta, gamma, A, B, C, right? So student number 1 recorded 1.95 and 1.93, whereas the correct value was 2 gram. He recorded 1.95 and 1.93. So his data, his measurements are precise because they are very close to each other, but they are not accurate. They are not accurate because correct value is 2. Student B is completely gone case because his values are neither accurate. Why? Because they are not close to 2 and they are very far apart from each other. So therefore they are not precise as well. So student B is neither precise nor accurate. Student C is the best one who has recorded the values close enough and they are close to the true value also. So this is C is both precise and accurate because the correct value, my dear kids, is equals to 2, right? So this is both precise and accurate. A is only precise and B is none. So this same example is there in NCERT exemplar. Just in case you get lucky, this could be a probable question in the NEET 2026 exam. Right, everybody. So far all good, everyone. Moving forward, let's go ahead. So next after this, we will come to the solved example straight away. Before that, do have a look at the laws of chemical combination as well, okay? Because recently in the last 2 years, in JEE Mains, they have asked few questions based on this. So in the laws of chemical combination, law of conservation of mass is very simple. Mass can neither be created nor be destroyed. Everybody knows about it, right? Law of definite proportions. Okay, also remember the names of the scientists who have given them, maybe just in case if you want to have a look. So law of conservation of mass beta was given by whom? It was given by Anthony Lavoisier. It says mass can neither be created nor be destroyed. Law of definite proportions. Law of definite proportions was given by Joseph Proust. And definite proportion says that a given compound, that is water, if you take, like for example, water, we all know, everybody, is H2O, right? All of us know that water is H2O. So now this water is rainwater, gutter water, river water, sea water. It will always have the formula H2O. And it will always contain hydrogen and oxygen. Now, you have 2 moles of hydrogen here. So suppose you have 1 mole water, that is going to have 2 gram of hydrogen and beta 16 gram of oxygen. So that ratio will always be 1:8. No matter from where this water is coming. Definite. Definite means what? Fixed, right? Definite means fixed, everybody. So this is the law of definite proportion. Any compound always has same proportion of elements by weight, right? It is also known as law of definite composition. That is, any compound will have the same composition. Then after this, we come to law of multiple proportion, guys. Multiple proportion. Now, this is a very probable question. Just in case if you get lucky, like they will give you data. Which of the following illustrates the law of multiple proportions? This type of 4 options could be given to you, right? So whenever you have to talk about the law of multiple proportion, remember what is the trick to identify which of the following illustrates the law of multiple proportion. The trick to identify is that you should have two elements, and those 2 elements beta should be forming more than one type of compound. Like for example, you talk about nitrogen and oxygen. So nitrogen and oxygen can form NO, they can form NO2, okay, they can form N2O3, they can form N2O5. So these examples, different compounds between two elements forming different compounds. This illustrates law of multiple proportion. This is illustrating law of multiple proportion. Please remember that. Okay, this is illustrating law of multiple proportion. And who gave this law, everybody? This law was given by Shri John Dalton Garu, very famous chemist who had made a lot of contributions. And what is the law? So for that you can maybe consider, let's say, hydrogen oxygen example. I can take H2O and H2O2. So two elements forming different compounds. So this illustrates your law of multiple proportion. What is the law? See, hydrogen mass is fixed. 2H means if you consider 1 mole, then here you have 2 gram hydrogen, 16 gram oxygen. And here if you consider 1 mole, here you have 2 gram hydrogen and 32 gram oxygen. So if you fix the mass of one of the elements, hydrogen mass fixed, hydrogen mass constant, right everybody? Now oxygen mass is how much? Ratio 1:2. 16 upon 32 is 1:2. Everybody can do that, right everyone? So this is the law. That is, if you fix the mass of one, then the masses of other that will combine, that will be in simple whole number ratio. All right, so this is the law of multiple proportions. So 3 laws we have covered: conservation of mass, definite composition, which is also known as definite proportion, and the law of multiple proportions, which was given by Shri Dalton Garu. Now next after this, so here we can erase it. This is done, everybody. Okay. Then after this, beta, we can come to the two very important hidden points are over here, which you should pay attention to. Next, we can talk about the law of Gay-Lussac's law of gaseous volumes. So Gay-Lussac's law simply basically, see, you know that for gases, volume is proportional to moles. Na? For gases, volume is proportional to moles. So if you consider any gaseous reaction, right? Let's say, for example, I write, let's say 2H2 gas plus O2 gas goes to 2H2O gas. Okay. Now for gases, volume ratio and mole ratio are the same if the measurements are being made at the same temperature and pressure. So normally you would say that in this reaction, beta, what is happening normally from stoichiometry? What is the interpretation, everybody? That 2 moles of hydrogen reacts with 1 mole of oxygen to give you 2 mole of water. 2:1:2. Now, this is in terms of moles, but this same logic will apply in terms of volume as well, guys, because for gases, V proportional to N. So you can see over here that 50 ml of oxygen, 100 ml of hydrogen, that is 1:2 ratio. And over here you will have what? 100 ml of water. So that ratio will remain the same in terms of volume. But provided all gases are at the same temperature and pressure, go through the statement carefully. When gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. For a moment, it might seem to you, sir, this is so, so easy thing, such a chiller thing, why Gay-Lussac was given so much credit for this. Beta, Gay-Lussac, it is a chiller thing for you because you know that hydrogen is H2 and oxygen is O2. Gay-Lussac did not know that. Gay-Lussac found this out experimentally by doing the measurements. So that is why some credit is given to him. Okay. And here, chala important point by everybody, chala important point. Gay-Lussac's law is simply the law of definite proportions. This law of definite proportions, which was given by Proust, this was in terms of mass. Gay-Lussac's law is definite proportions in terms of volume. So it is a special case of law of definite proportion. Please do not miss this point. Okay, in case you are lucky, this can come in statement form in NEET exam. Ki Gay-Lussac's law is volume relationship and is actually the law of definite proportions by volume. Now you can say, sir, but how definite proportion was that a compound will have the same elements? Like over there, when I was discussing about water, so over there I had said that for formation of water, hydrogen and oxygen will combine 2 gram and 16 gram, that is 1:8 mass ratio. And this mass ratio would be fixed, everybody. Right, all of you? This mass ratio would always be 1:8. This is what we discussed in case of definite proportion by mass. But over here, sir, how is it definite proportion? Beta, here I am saying that when water will be formed, hydrogen and oxygen will always combine in 2:1 ratio by volume. So this ratio will also be fixed, na? This ratio will also be fixed, but it is in terms of volume. So in a way, what is the moral of the story, everybody? In a way, Gay-Lussac's law is nothing but law of definite proportion in volume terms. Law of definite proportion was in terms of mass. Is this okay? At least the online people can respond. Have you understood this point which I am trying to explain over here, everybody? Right, all of you? The people who are connected by Zoom, law of definite proportion. Great. Okay, so it is in terms of volume. Please remember that. Awesome, awesome, amazing, amazing. Chala bahundi. Avogadro's law, very simple. Yes, 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 very good, very good. So those people who are connected by Zoom, once if I ask you a question, just type why, yes, no, whatever. Okay, so that I understand that you are understanding. Okay, because my understanding that you are understanding is dependent on the fact whether you are responding or not. All right, so next after this, everybody, we come to Avogadro's law. And Avogadro's law, chala simple. It says by equal volumes of all gases under similar conditions of pressure and temperature, similar gas state law. If pressure, temperature is same, volume is same, then number of molecules or number of moles will be same. And you can understand one thing over here, that the distinction between atom and molecule, like before Avogadro, Dalton and all used to think that hydrogen is what? H, oxygen is O. But Avogadro was the first person who said, no, hydrogen is not H, it is H2. Oxygen is O2, nitrogen is N2. So he made the distinction between atom and molecules. So this point also we can keep in mind. All right, kids. So that was about law of this topic. Please have a look at it. Okay, go through this one page only. Precision, accuracy, you have a look, and then go through law of chemical combinations. Then moving forward, this is all very simple basic stuff. No need to waste too much time on this. Yes, next important topic is average atomic mass. So what is average atomic mass? By everybody knows about it. How do we calculate the average atomic mass? It is the weighted average. It is the weighted average of all the isotopic masses. So different isotopes are there. They will have different masses, and we take their average according to their percentage abundance, right? That percentage abundance and all is given to us in the problem. So like one example is given over here. Okay, so these are the 3 isotopes of carbon. I am sure everybody knows what isotopes are. So carbon 12 is there, 13 is there, 14 is there. These are their abundances. Okay, so what do we do over here? Normally this is NCERT data, so you know they are not very friendly with regards to numbers and calculations. If this problem has to come in need, then they will give you simplified data, like maybe they will give you 98, this they will give you 1. So over there what you will do is Dalton's theory, beta, you can just have a look. 4 points are there. Just have a look at it once, go through it. We are covering, see, on an average, we have around 30 to 35 minutes per chapter. Okay, so we will like to, and in that we have to practice the important problems from the solved examples as well as the exercises. Okay. So everybody, so how will you approach such a problem? Everyone quickly tell me. So percentages would be given. So this into 12 plus this value into 13 plus this value which is very small into 14 divided by 100. I'm sure you all must be knowing the formula. For average atomic mass, what will we do? A1 M1 plus A2 M2 upon A1 plus A2. So using this you can easily calculate the average atomic mass. Not that. What is A1? A1 is the percentage abundance. Sorry. A1 plus A2 will actually be equals to 100. So A1 and A2 are the percentage abundance. And M1 and M2, everybody, M1 and M2, they are the isotopic masses. So one very famous example of this is that of chlorine. Like for example, if I put an exact data over here. So chlorine is 35 and chlorine is what, everybody? 37, right? And let's say this is given to you as 75% and this is given to you as this kind of question you can expect in NEET. So what will you do over here? I'm not solving it for you. I'll just tell you the concept. So the average of this you will take. So 75 into 35 plus 25 into 37 upon 75 plus 25. This is how you will calculate the average atomic mass, and you should remember that average atomic mass, the atomic mass is always the average. We always have to consider the average of all the different isotopes. So like this we can do, not that difficult to manage, fairly simple thing. Okay guys, moving ahead. Next over here, very quickly, I will explain to you the meaning of, yes, this term, formula mass. What is formula mass, everybody? Formula mass is like molar mass only, but for ionic compounds. Like ionic compounds, I cannot say they have a molecule. Na? It's not like NaCl. NaCl, beta, NaCl is not a molecule. NaCl is Na plus and Cl minus. So this unit of an ionic compound, is not called a molecule. This unit of an ionic compound is not called a molecule. It is called a formula unit, the simplest unit of that. And it is like molar mass only, but for ionic compounds. So this is known as formula unit. And the mass of one such unit, will be known as what, everybody? It will be known as formula mass. Is this understood, boys and girls? What is the meaning of formula mass over here, everybody? All of you. Meaning of formula mass, average atomic mass, right? So formula mass is nothing but for an ionic compound. Now after this, we come to the first solved example. That is problem 1.1. Calculate the molecular mass of glucose. Very, very simple example, not that difficult. But you need to understand over here there are three things. Like first of all, you have relative atomic mass, then you have atomic mass, and then you have gram atomic mass. Let's say I take the example of helium. So helium relative atomic mass is equals to 4. It is just a number. Helium relative atomic mass is equals to 4. It is just a number, right? In comparison to 1/12 of carbon atom, you know that. Atomic mass of helium is 4 AMU or 4U. What does this represent, everybody? This represents the mass of one atom of helium. Okay. This represents the mass of one atom of helium, 4 AMU or 4U. And gram atomic mass of helium is 4 gram. And this represents the mass. This is the mass of how many atoms? One atom. And this is the mass of how many atoms? 1 mole atoms. 1 mole atoms means 6.02 into 10 to the power 23 atoms. So kindly remember this point. This is important. That, and the same logic will apply for molecule also. So if the question is asking for molecular mass, then you have to tell the mass of one molecule in AMU. So my dear kids, glucose is C6H12O6, right? And you have 6 carbons, so you can simply add it, 6 into 12 plus 12 hydrogens. Hydrogen is 12 into 1 plus 6 oxygens, that is 6 into 16. So this is 72 plus 12 plus 16, 6 are 96. If you will total it, you will get 180 around. But question is asking for molecular mass. So molecular mass means mass of one molecule, which will be 180 AMU or 180 U. Please remember this. Okay. If I would ask you the molar mass or the gram molecular mass or molar mass, then you will go for 180 gram. So read the question very carefully. If in this question I set and one option I give as 180, other I give as 180 U, other I give as 180 gram. And if you select this or this, -1. Understood, everybody? Molecular mass is mass of one molecule. gram molecular mass is mass of 1 mole molecules, which is 6.02 into 10 to the power 23 molecules. Right, everybody? So I hope, boys and girls, everybody has understood what I'm trying to say. So if they are asking for gram molecular mass, make sure what you are going to select, right? And I hope you know the AMU conversion as well. 1 AMU is equals to 1.66 into 10 to the power minus 24 gram is equals to 1.66 into 10 to the power minus 27 kilogram. This is 1 AMU. Right, moving forward, percentage composition, very simple. Everybody knows how to do that. Next, we will move on to problem number 1.2. Problem number 1.2, let's quickly have a look at it. Okay. So this is conversion for AMU. This everybody has understood. All right. So next after this, we talk about problem 1.2 solved example from NCERT. What is this example trying to tell us? A compound contains hydrogen, carbon and chlorine. Their masses ratio are given. Molar mass is also given. And we have to find out the empirical and the molecular formula. Everybody understands what is the difference between empirical and molecular formula? Empirical formula is the simplest whole number ratio. Molecular formula is the actual number of atoms. So what are the elements present over here, boys and girls? Elements present over here are carbon and hydrogen and chlorine. How much carbon is there? In 100 gram, I have 24.27 around grams. I can write if I want. Hydrogen is 4.07 grams. And chlorine is how much, beta? 71.65 gram. Now, our first step is to convert all of this. Our first step is to convert all of this into moles. So, what do we do? Given mass by molar mass, carbon is 12, hydrogen is 1, and chlorine is given mass by molar mass, 35.5. We convert them into moles. Now, this is almost 2 moles. This is almost 4 moles. And this is almost 2 moles. But will you write C2H4Cl2? No, 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 no. You have to write the simplest whole number ratio. So this entire thing can be divided by 2. And if this will be divided by 2, I will get 1:2:1. So empirical formula, everybody, you can have a look, is how much? It is empirical formula CH2Cl. CH2Cl. Is this okay, boys and girls? This is how you calculate the empirical formula. All right. And then after this, you have to find the molecular formula as well. So for molecular formula, what do I do, everyone? For molecular formula, I do N is equals to molar mass upon empirical formula mass. Molar mass upon empirical formula mass. So how much is molar mass given in the question? Everybody have a look. Molar mass is 98.96. Around 99 is given. Okay. This is the molar mass. And empirical formula I had got as how much, everybody? CH2Cl. CH2Cl. This was the empirical formula, right, everyone? So empirical formula mass, how will I calculate this, everyone? Think quickly. So chlorine is 35.5. Carbon is 12 and 2 14. So 35 plus 14, 49.5. So this is around 49.5, which means the multiplying factor is 2. Multiplying factor is 2. Please sit, please practice along with me. Please practice along with me, right? So means you need to multiply this empirical formula by into 2, right? And your molecular formula will be C2H4Cl2. So you can have a look over here, C2H4Cl2, right? Now moving forward, yes, please, this type of question has been asked. What do the balanced equation represents? Pay attention, everybody. Now we come to stoichiometry part. Suppose I write down an equation, students, CH4 plus 2O2 goes to CO2 plus 2H2O. Okay, this is the balanced equation I have written. Now what information do I get from a balanced chemical equation? This one type of question JEE Advanced has been also asked, and it has appeared in your PACE and FACE exams as well earlier. Okay, what I'm trying to say, I'll explain. So what information do I get from a balanced chemical equation? You know the balancing numbers are known as stoichiometric coefficients, everybody. So the stoichiometric coefficients represent the mole ratio. Okay, this represents 1 mole methane, 2 mole oxygen, 1 mole CO2, 2 mole H2O. Reactants are consumed, products are formed, right? Then it also represents 1 molecule of methane, 2 molecules of O2, giving you 1 molecule of CO2 and 2 molecules of water. Then it also represents, if it is a gas phase reaction, it also represents volume ratio. If it is a gas phase reaction, that is 1 liters of methane, 2 liters of oxygen consumed to form 1 liter CO2 and 2 liters of H2O. So it represents the mole ratio, it represents the ratio of molecules, reactants and products. It represents the volume ratio if it is a gas phase reaction. If it is a gas phase reaction, it represents a molecule ratio. Volume ratio, but it is not the mass ratio. Please note, you cannot say 1 gram methane and 2 gram oxygen. It is not the mass ratio. This is a very crucial point which you will find over here in the last line. And it is equals to the volume ratio, that is 1:2 only for a gas phase reaction, not for aqueous solution or something like this. One JEE question is also built around this concept where they are saying Al plus HCl aqueous is reacting. So for Al and HCl, Al is a solid, HCl is aqueous. So over there, the stoichiometric coefficients will not represent the volume ratio. They will not, stoichiometric coefficients will represent the volume ratio only in case of a gas reaction. So kindly remember this point. This is very crucial. Okay. Now, so I hope everybody has understood this so far. Moving forward, next we talk about some more solved examples over here. So this problem number 1.3 and 1.4 are based on this same reaction which we have written over here. So very quickly we can have a look at it. Calculate the amount of water, G means in gram, produced by combustion of 16 gram of methane. So 16 gram of methane is getting combusted, and how much water will be produced over here. So you know, simply you have to apply the grandpa equation over here. What will you do, beta? Moles of methane consumed upon 1 is equals to moles of water formed upon 2. Moles of water formed upon 2. Moles upon stoichiometric is equals to moles upon stoichiometric. These two I am not considering because I have to relate methane with water. Right, everybody? Methane with water. So methane 16 gram, molar mass of methane is 16. So that is 1 mole of methane. So moles of water formed will be equals to how much, everyone? 2 mole. But this is 16. So 16 by 16, 1 mole. So 2 mole water. And mass of water will be equal to 2 into molar mass of water. A molar mass of water is how much, everybody? 18 gram per mole. So once you will solve this, what are you going to get? You are going to get 36 gram of water. Question problem number 1.4 is also based upon the same reaction, but different thing is being asked. Okay. So 1.4, quickly everybody, take 30 seconds, try to solve it. In the meantime, I'll just have some water, and then we will discuss 1.4 as well. Take 30 seconds, solve it quickly. Okay, so what are they asking? How many moles of methane are required to produce 22 gram CO2? You can do it orally, boys and girls. 22 gram CO2 means how many moles of CO2? This I am removing from here because I want to use the same equation. Okay, right. So beta, 22 gram of CO2 means 0.5 mole, na? 22 gram of CO2 means given mass by molar mass, that is 0.5 mole of CO2. And CO2 and methane mole ratio is 1:1. So if you want 0.5 mole of CO2 to be formed, how much methane you should take, assuming efficiency to be 100%? 0.5 mole. Bus 1:1 ratio. Apply the equation also. Moles of methane by 1 is equals to moles of CO2 by 1. Very simple. Chala easy problem. Stoichiometry is nothing but ratio and proportion. Just remember they represent ratios. That's it. It is very much similar to the 8th, 9th, 10th problems which you did na? When you were in while studying mathematics. You did ratio proportion problems. Ages of Ram and Shyam are in the ratio 2:3. Ram is 10 years old. So how old is Shyam? So it is simply that kind of a problem. Ki this is consumed this much, this is formed this much. So how much should the other one be taken? Just remember that for any stoichiometry question, finally if I sum it up, AA plus BB goes to CC plus DD. Okay, a balanced reaction. What do we write? Moles of A consumed upon A is equals to moles of B consumed upon B is equals to moles of C formed upon C. Space is not there. I will write it here. Moles of D formed upon D. So this is your basic equation of stoichiometry. If it is a gas phase reaction, you can write the same relation beta in terms of volume as well. Same relation can be written in terms of volume as well, right? So moles of A consumed upon A, B consumed upon B. Any one could be given. This could be given. Find how much C would be formed. This could be given. Find how much A would be consumed. So using this, you can write this. Just make sure, boys and girls, that the equation which you have is a balanced one. This is a very common error. Many times, trust me, you will falter and apply this equation without checking whether this is balanced or not. So make sure that the equation is balanced. Right, excellent. Moving forward, we come to problem number 1.5. 1.5, important question. Let's have a look. NCERT has given chala lengthy solution. We are not going to look at the solution. We will try to solve it by ourselves. Okay, by using the basic principles. So by over here, what is happening, everybody? Pay attention. This is an important problem. N2H2 are reacting to form ammonia. So N2, 1 minute. Yes, N2 plus 3H2 goes to 2NH3. This is the reaction that is happening. How much N2 I have taken, beta? N2 I have taken 50 kg. 50 kg means 50,000 gram. And hydrogen, how much I have taken, everybody? 10 kg. 10 kg means 10,000 gram. Okay. So these are their initial masses. Now question is asking how much ammonia would be formed. How much ammonia would be formed. So in such questions, first approach is ki bhai, first of all, we will convert it into, we have to find the moles, because I told you, this is the mole ratio and not the mass ratio. So you need to convert it into moles. So given mass by molar mass, given mass by molar mass. Hydrogen molar mass is how much, everybody? 2. So this is 10,000 by 2, that is equals to 5,000 mole for H. And N2 molar mass is how much? 28. So this is 50,000 by 28. Now beta, after this I want to find out the limiting reagent. How do we find out the limiting reagent? Moles of A upon A, moles of B upon B. You have to check the limiting reagent, everybody. You have solved numerous questions using this. Everything you know. The purpose of this class is just to remind you that you know. Okay, like Lord Hanuman forgot about his powers, na? So you are the Lord Hanumans of Sri Gosalites. Everything you know, it is there in your brain. It is there in your veins. It is running in your blood. You have just forgotten your powers, right? So given mass by molar mass is the, abhi I have calculated the moles, initial moles, okay? Now I will go for moles of A upon A, moles of B upon B. So this will become 5,000 by 3, 5,000 by 3, right? 5,000 by 3. And this will become 50,000 by 28 upon 1. So this will remain the same. But check the smart calculation I do over here. I write it as 5,000 upon 2.8. Don't go by the NCERT solution. 5,000 upon 2.8. By 110 I can divide over here, na? So now This is moles of A upon A, moles of B upon B. Which is smaller? Which is smaller? Numerator same, denominator bigger. So this fraction is smaller. This fraction is smaller means hydrogen becomes my limiting, nitrogen becomes my excess. So I will find the moles of ammonia using moles of hydrogen. And what equation will I apply? Acha, one more very common mistake. Okay, after you have done moles of A upon A, moles of B upon B, now there is no use of this. Because sometimes in place of moles of hydrogen, see, hydrogen is the limiting reagent, so I have to use hydrogen to calculate the product. Sometimes in case of moles of hydrogen, in a hurry, out of carelessness, you can use 5000 by 3. 5000 by 3 is not the moles of hydrogen. 5000 by 3 is moles upon stoichiometry. So once you have figured out the limiting reagent, after that there is no role of the fractions. Now use this to find ammonia. So moles of hydrogen upon 3. So 5000 upon 3 is equals to moles of ammonia by 2. So let's say X mole ammonia produced. I had to find out how much ammonia produced, everybody. So X moles ammonia produced, X upon 2 I will do over here. So ammonia becomes how much, everyone? Ammonia becomes 2 into 5000 by 3. This is the moles. But question is asking me for mass. So what will I do? Into molar mass. This is the moles. Into molar mass of ammonia is how much, everybody? 17. And if I want in kg, so I can divide this by 1000. So this 1000 will go and I will get the answer in kg. Did you understand the calculation, everyone? Cheppu, cheppu, twarga cheppu, fast, everybody. So if I want the answer in kg, I have divided it by 1000. This goes away. So I have 2 5s are 10 and 10 into 17, 170 by 3 kg. 170 by 3 kg I can solve. 3 5s are 15, 2 20, 6 are 18. 2 will be left. 56.66 or 67 kg should be my answer. 56.6. Okay, so this is 56.1 they have calculated. Maybe they must have used molar mass as fractional values, but this will be your relative answer. Is this okay, by boys and girls? Everybody, 1.008 they might have used. 2.016 they have used over here, na? I have used 2, they have used 2.016, so little bit difference coming, but don't worry. This is your nearby answer. Is this okay by everyone, all of you? Okay. Then after this, very quickly, stoichiometry over. We come to concentration terms now, everybody. So concentration terms, one very probable question is which concentration term is dependent on temperature, which is not dependent on temperature. So wherever volume comes, molarity, moles upon volume in liter, percent m by v, mass of solute in gram upon volume in ml into 100. Then after that, strength in gram per liter. These concentration terms, wherever percent v by v, wherever volume comes, they depend on temperature. Then after that, wherever volume does not come, molality, moles of solute upon mass of solvent in kg. Then after that, mole fraction. Then after that, ppm mass by mass. They are independent of temperature. So remember this. Then after this, you should know the formulas for all the concentration terms, right? Let's have a look at problem number 1.6, everybody, quickly. A solution is prepared by adding 2 gram of water. A solution is prepared by adding 2 gram of substance to 18 gram of water. Calculate the mass percent of the solute. Acha, here also read very, very carefully. Read very, very carefully whether mass percent of the solute is written or mass percent of the solvent is written. So here I have to find mass percent of the solute. Who is the solute? A. So beta, percent m by m will be equals to mass of solute, that is 2 gram, upon total mass of solution, that is 20, 2 plus 18 into 100. So very simple over here, 10% m by m I get as my answer. 10% m by m I get as my answer. But read the question carefully. If somebody is trying to trap you, they have written mass percent of the solvent, then your answer won't be 10%, then it would be 90%. Quite common sense, I hope everybody can understand. Okay, moving forward, in case of molarity, 2 very important concepts are there, dilution formula and mixture formula. So dilution formula, everybody, dilution formula in case of molarity, what is it, beta? It is M1V1 is equals to M2V2. M1V1 is equals to M2V2, right? This is dilution formula. And remember that in dilution formula, this V2 is the final total volume. Like this is a very common mistake which many of you would make. I would say initial solution is 200 ml. In this initial solution of 200 ml, I have added 300 ml of water. 300 ml of water. So what is the value of V2? You have to put in the formula. V2 is the final total volume. Don't put 300 over here. Very common mistake. V2, my dear kids, will be equals to 500 ml. 200 plus 300 will be equals to 500 ml. Please remember that. Yes. So this is a very careless mistake which people usually make. So remember, V2 is the final total volume. Then after this, you have the mixture formula. Mixture formula, resultant molarity is equals to what? M1V1 plus M2V2 upon V1 plus V2. M1V1 plus M2V2 upon V1 plus V2. One special case of this, remember that in case the question comes, it will save some of your time. If V1 equal to V2, if both the solutions have the same volume, which many times will happen, then final molarity beta is simply equals to M1 plus M2 by 2. Please remember the special case of this. You can easily check this out by putting V and V over here. Both V1 and V2 are equal. Let's call them V. So you will get V, V and 2V. So you will get M1 plus M2 by 2. Okay, very quickly moving ahead. This solved example, everybody can have a look. You should try this on your own. This is DIY problem. DIY means do it yourself. So 4 gram NaOH, 250 ml of solution. 4 gram NaOH, 250 ml of solution. You can calculate the moles by volume in liter. So very quickly, if we have a look at it, molarity, my dear kids, will be equals to, read the problem carefully. Calculate the molarity of solution prepared by dissolving 4 gram of NaOH in enough quantity of water to form 250 ml. So beta NaOH molar mass, if you will add, you will get 40. So 4 gram means given mass, always do given mass by molar mass. Okay, so moles of NaOH is 0.1, don't say 10. Moles of NaOH is 0.1, right? And everybody, what is the volume of the solution? Volume of the solution we are saying is 250 ml. So 250 ml means 250, but I have to put in liters. So you know whenever this volume is in ml, you have to multiply by 1000. So boys and girls, your molarity is 0.4 molar. This will cancel 4 times, na? So 0.4 molar you will get. And finally, the last one, example is interconversion of concentration term. Molarity is given, density is given. So for that, either you can go by this basic method, or for molarity, you can directly use the formula also. Molarity relation, you know, M is equals to 1000 into M upon, this is Chinna M, this is Pedda M. Chinna M means molality, Pedda M means molarity, upon 1000 into D minus molarity into molecular weight of solute. Molecular weight of solute. So using this logic, you can calculate the molality. Okay, either you can go by the fundamental method also, or directly you can use. But when you are using this formula, remember your density should be in gram per ml. Gram per ml, right? So you can put the values over here. Okay. So this is the direct conversion formula. So you can put the values 1000 into 3. Molarity is given to you as 3. Upon 1000 into D. Gram per ml or gram per cc is also the same. I hope you know that. So 1250 will come here. 1250. Okay, 1.25. 1.25 into 1000. 1250 minus molarity into mol. So 3 into NaCl molar mass is 58.5. So 58.5 into 3 will be 180 में से 4.5 I can minus. So it will be 175 something. 176 around, if I am not wrong. So around 175, 176 you will get. 175.5. Okay, 175 something you will get. So you can now solve it and calculate the molality value. Is this understood, boys and girls? And do remember the formulas of the concentration terms. Molality is the, and one very common mistake in molality, many times you will put mass of the solution. Remember, you have to put the mass of solvent in kg. And over here, this point also you should know that a solution of desired concentration in laboratory is prepared by diluting a solution of higher concentration. The solution of higher concentration is also known as the Stock solution. What is the Stock solution? That definition has been given. Then in your NCERT, few problems I have circled. These ones you should definitely have a look, especially 1.3. In 1.3 beta, empirical formula you have to find out iron is there and dioxygen is there. Now how much iron is there and oxygen is there? Iron is 70 gram and oxygen is, let's say, around 30 gram, right? Now many people, they get confused by this dioxygen. See, they are saying dioxygen there, but oxygen in a compound will be present as an atom only, na? Like for iron, everybody will divide by 56. Listen to me. But over here, some students would say, ki sir, there dioxygen written, sir. For iron, you would divide by empirical formula you have to find out. So you would divide by 56. But here some students would say, sir, dioxygen written over here. So I would divide by what, sir? I would divide by 32. Okay. Okay, no problem. Divide by 32. But then write O2 over here, na? If you want to divide by O2, if you want to divide by 32, write O2. And then when you have to write the formula, you have to find the moles of O, not moles of O2. O is present as atoms in a compound, not as molecules, right? So better is let it be O and divide it by 16 only. Okay, divide it by 16, you will get whatever the answer is. Okay, so this will get cancelled out. This will become how much by? This will become 5 by 4 mole. If I am correct, 14 5s are 14 4s are, yes. And this will become how much, everybody? This will get divided by 2. So this is 15 by 8 moles. 15 by 8 moles. I can multiply this by 2. So this will become 8 and this will become 10. 8 8 cancel. 10 is to 15. Answer is Fe2O3. So please remember this. Please remember this. If you are dividing by 32, then you should consider O2 over here. But to write the formula, you need moles of O, not moles of O2. Is this making sense, everybody? Okay, similar question is there, one more. That is the more clearer version of the same problem, 1.8. Then 1.10 definitely you must try. 1.10 in 3 moles of ethane. In 3 moles of ethane, how many moles of carbon are? This is also an important one. Beta C2H6, 1 mole, remember this analysis, okay? C2H6, 1 mole of this compound has 2 moles of carbon and 6 moles of hydrogen. Please remember this. 2 moles of carbon and 6 moles of hydrogen. 1 mole of the compound has 2 moles carbon, 6 moles, rest you can do quickly. So in 3 moles, how many moles of carbon? 2 into 3, 6 moles. How many moles of hydrogen? 6 into 3, 18 moles. So this you can do, this you can do. Number of molecules, though, you can easily solve 3 into 6.02 into 10 to the power 23, you will get the answer. Did you understand this by 1.10? Everybody clear? 1 mole of ethane contains 2 moles of carbon and 6 Telugu, I don't know. Okati rendu mudu, I do something 6. Okay, so 6 moles of hydrogen in 1 mole. So 3 moles mein what will this become? 2 will become into 3 and 6 will also become into 3. Is this understood, everybody? All of you got it? Cheppu fast. Then do this question after the class. DIY, match the column so that you learn the units. And then this is a neat PYQ. This one you can solve. Which of the following will have the largest number of atoms? Okay, so when you are going for atoms, do remember to multiply by the atomicity. So 1 gram Au, 1 gram Na, 1 gram lithium atomic masses would be given. So 1 gram Au will have how many atoms? 1 upon gold atomic mass, I think is 197. Okay, whatever it is, it will be given. I will illustrate with sodium. Sodium 1 gram will have how many atoms? 1 upon 23 into Na. 1 gram lithium will have how many atoms? 1 by 7 into Na. 1 gram Cl2 will have how many atoms? 1 upon Cl2 molar mass is 71, given mass by molar mass, into Na is the number of molecules into 2. Sir, why did you not do this into 2 beforehand? Beta, they were all monoatomic, na? So they were all monoatomic, but this is diatomic. So please take care of this concept. This is also important, right? And finally, the last question over here. Number of atoms in 52 moles of Ar. 52 moles of Ar is important question, everybody. 52 into Na. 52U of helium. 52U is written. One mass is 4 AMU. So that will be 52 upon 4. 13. 13 4s are 52. So this is 13 atoms. Because this is given in 52U, not 52 gram. And 52 gram will have 13 moles. 52 AMU will have 13 atoms. Okay, 13 4s are 52. And 52 gram beta will have 13 moles. So 52 gram upon 4 gram per mole. So you will be having 13 moles. That is 13 into Na. So I hope you very clearly understand the difference between 2 and 3. Is this okay, everyone? Yes, boys and girls, understood? Got it, everybody? So now we move on to the next chapter, that is atomic structure. Mole concept is done. You can also practice this 1.34 question. Revise that equation. CXHY plus X plus Y by 4. Okay. CXHY plus X plus Y by 4 O2 goes to X CO2 plus Y by 2 H2O. So everybody please have a look at this equation also. You will use it to solve question number 1.34. Is this done, boys and girls, everybody? Okay, so let's move ahead. This is done. Next chapter we pick up is your atomic structure, right? Structure of atom. So we copy this from here. We go to the public cloud. 1 minute. And 1 minute. Structure of atom. Yes. So structure of atom, everybody. 1 minute. One second. Just give me a minute. One second. Yes. Why is it? Okay, no worries. We will do it from here only. I'll keep on shifting to the 1 minute. So, and 1 second, just 2 minutes, Why is it? Okay, don't worry, we'll do it on the full screen only. Okay, no issues. So let's come to structure of atom, everybody. So mole concept, please make sure that you go through the questions which we have done. All right, so structure of atom begins with the discovery of subatomic particles. In the discovery of subatomic particles, we have the cathode ray experiment, the anode ray experiment. So you all know that cathode ray experiment, everybody, led to what? Cathode ray experiment led to the discovery of electrons, right? So some of the important points on which you should focus over here, definitely everybody, are first of all the E by M value of electron, and for cathode ray experiment from which electron was discovered, the charge to mass ratio was independent of the nature of the gas and the nature of the discharge tube, right? I mean the nature of the electrodes. So this is an important point. And then who was the scientist beta who determined the E by M value, everybody? It was none other than Shri J.J. Thomson. So J.J. Thomson determined the E by M value, right? And for that he carried out an experiment. Some deflections and all were done, everybody. And the deflections depend on what? The deflections depend upon, please have a look at it. This is important, right? So everybody, deflections are directly proportional to, so this point you have to remember, everyone, that deflection is directly proportional to the magnitude of charge. Remember these 3 points, they are important. Deflection is directly proportional to the magnitude of charge, and then after that deflection is inversely proportional to the mass, okay? And then after that deflection is directly proportional to the electric field. Okay, just give me 1 second and have a look at it. I'll just try to figure out how to do that split screen. Just give me 1 minute, okay? So happy finally. Target achieved, boys and girls. Target achieved. Thank you. I was missing something. See, this is actually one feature which we don't regularly use in the class. So that is why sometimes you get unaware. Okay, thank you Achyut for your kind words. I appreciate that, for your advice. Let's have some water in the meantime and then we'll continue. So please go through the 3 points, everybody, all right? Okay, everybody. So now all of you, so as we were discussing, deflection is, yes, very quickly, deflection is directly proportional to charge, deflection is inversely proportional to mass, and deflection is directly proportional to strength of electric and magnetic field. 2 important points from here which you should know are, number 1, for cathode ray, E by M is independent of nature of gas. For anode ray, which are also known as canard rays, E by m depends on the nature of the gas. So please remember that, everybody. Okay. Remember this 1.76 into 10 to the power 11 coulomb per kg charge by mass value. Who determined? Thomson calculated charge by mass. Who calculated charge? Shri Millikan Garu. Millikan Garu calculated the charge on electron. This is Millikan's oil drop experiment. Don't bother too much. In case a question has to come, it will be based upon, just remember the three forces that are acting on the oil droplet. What are the three forces? Gravitational force, electrostatic force, and the viscous drag. Viscous drag means that, which you study in physics, na 6 pi eta RV. 6 pi eta RV. That is the three forces acting on the Millikan oil drop experiment. This point also, in case of anode rays, what happens, boys and girls? Gases get ionized, na? So let's say neon is there. So if due to high voltage neon will ionize, beta, what will happen? You will get Ne plus plus electron. But some atoms can also lose 2 electrons. Neon has atomic number 10 here. So 2 electrons are there. So you can also get what over here? Ne2 plus plus 2 electron. So that is why they have mentioned some of the positively charged particles carry a multiple of the fundamental unit. Fundamental unit means what? E, na? So they can carry multiple of fundamental unit of charge, right? So that's it. Let's move forward. This table I hope everybody knows. Okay. Charges. Remember, neutron is slightly heavier than a proton. Although for practical purposes we take 1 AMU, but neutron is slightly heavier than a proton. Electron is almost massless. Then this is all kiddie stuff. Rutherford model. This point, please keep in mind, size of nucleus minus, if you are lucky, this can come. If you are lucky, and you all are lucky. Okay. All of you are lucky. Trust me. Fortune favors the brave. The radius of atom is around 10 to the power minus 10 meter, and nucleus is around 10 to the power minus 15 meter. Then after this, we'll move forward. We'll try it. This point you should know. Yes, isotopes. Yes, isotopes have different physical but same chemical properties. Read this line carefully. Chemical properties of atoms are controlled by the number of electrons, which are determined by the number of protons. Number of neutrons present in the nucleus have very little. And isotope, isobar, to everybody knows, na? Isotope, isobar, isoelectronic, chiller concepts. Very easy. Okay, so simple. Number of neutrons have very little effect on the chemical properties of the element. Therefore, all the isotopes show same chemical behavior. In true, false, assertion, reason, statement 1, statement 2, this can be asked. Example 2.1, solving it would be disrespecting you. They are asking number of proton, neutron, electron. You can do that. Proton is 35, neutron is 80 minus 35. Since it is neutral, electron is also 35. 2.2 also, I don't want to disrespect you. You can easily do that. Okay, very simple. Have a look at it. Then after this, drawbacks of Rutherford's model, boys and girls. Drawbacks of Rutherford model, it does not explain the Maxwell's theory. Okay, accelerated charge particle. Remember this. Many people think charge particle should radiate energy. No, accelerated charge particle. Okay, so when electron is moving, Rutherford had said electron is moving in circular orbit. So that electron will gradually lose energy. Ding, 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 tadap. It will fall in the nucleus. So Shri Rutherford Garu had no answer for this. So we will focus on the most important things of the chapter. Don't worry about that. So this is it. This is it, everybody. And this could not explain. And highlight this point. Maybe it is asked 10 to the power minus 8 second. It will take to spiral in the nucleus. We will jump to Bohr's model now, guys. Okay, Bohr's model is important. But before that, some important points in the electromagnetic wave theory. So over here, I hope everyone knows gamma rays, X-rays, UV, infrared, all that. In radio waves, we have two parts. This is in order of decreasing frequency, increasing wavelength. So we have two parts over here, FM, AM. So remember this, many people miss this, hai na? FM, AM. FM is lower wavelength, AM is frequency modulation. वो radio सुनते हैं ना? 98.3 FM, idi chala hot guru, or something like that. Okay, they say on the FM. So remember this, idi chala hot guru, FM, AM, right? So then after this, moving forward, speed of light and all, everyone knows. We will come on to the more important ones actually. So Vivid Bharati station, this is a NEET PYQ actually, same question has been asked. So 2-3 problems are there. One maybe I will do for you. One I will do, and other two you can do on your own, just to give you a hang of the calculation. So let me pick up the one with the toughest calculation. So let's go with 2.5. 2.3 is need PYQ. 2.4 chala easy calculation. You can easily manage that. C equal to nu into lambda you have to apply. Here also C equal to nu into lambda you have to apply. This one is involving some concepts. So 2.5, boys and girls, I will discuss. So find the wave number of radiation having wavelength 5800 angstrom, and let's say I want the answer in meter inverse. So bhai nu bar equal to 1 upon lambda, written in holy books of chemistry, wave number, okay? And 1 by lambda is equals to 1 upon 5800. I told you in the beginning of mole concept, angstrom and all can come over here, everybody. Okay, focus everyone. It is, I can understand that after some time, your brain will send signals to you to take a break or something like that. Just have a sip of water and focus. Okay, grind. Okay, this is the time where you have to really put in all that you have, right? So 1 upon 5800 angstrom. Arey bhai, that is how you will perform a 5-hour surgery successfully later on, na? If your mind can stay focused for 3-4 hours, that is how you will do the 5-hour surgery. Throughout the surgery, you have to be very focused. We keep on hearing in news for 4 hours, doctor performed the surgery and for that much time you need to be focused, right? So 5800 into 10 to the power minus 10. I will write it as, see, check the, how do I make smartly the approximations while doing the calculation? So this is 10 to the power minus 8. This is in meter. So this will become meter inverse. So this is minus 8, this will become plus 8 upon 58, and meter inverse, you can understand every time, no need to write. 10 to the power 8, boys and girls, will be written as 100 into 10 to the power 6 upon 58. Now by 100 upon 50 is 2. So this quantity will be little bit less than 2, around 1.7, 1.8 into 10 to the power 6 meter inverse. Now I will go back to my question and see the answer. 1.7. Trust me, I had not seen the answer. Aap bologe, sir, you must have seen the answer. No, seriously, I have guessed that. 1.7 into 10 to the power 6 meter inverse. If you want, you can convert it into centimeter inverse also. Next, he is asking me to calculate the wavelength. Next he is asking me to calculate the frequency. Chalo bhai, let us calculate frequency, everybody. This little bit I will shift over here. Okay, so nice. Okay. So frequency, I will once again use the formula, everybody. C is equals to nu into lambda. C into 3 into 10 to the power. Solve the questions along with me. Don't watch me solving. I don't have to give NEET exam. You have to give the NEET exam. Precision, accuracy. Just know you have studied. These things will matter. Not precision, accuracy will matter in NEET, right? So make sure that you do it. So 3 into 10 to the power 8 meter per second. And unit and all, everybody understands. You all are not kids. So we will move forward. Frequency I have to find. Lambda is how much, everybody? 5800. So that is 5800 into 10 to the power minus 10. So now from here I get nu is equals to 3 into 10 to the power 8 upon 58 into 10 to the power minus 8. 58 into 10 to the power minus 8, right? So this becomes how much, everybody? This becomes, will it move for, no, okay. So this becomes 3 into 10 to the power, 3 into 10 to the power of 16. Okay, focus on the calculation beta, by 58. Ab dekho, 200s I will give to this. 200s I will give to this. Gyan Prakash, sir, in this remaining time, it is better to read the NCERT full or just underlined important lines would be enough. Gyan, तुमने बहुत ज्ञान की बात करी है, okay, and I will share my gyan with you definitely. Do you have the time to read full NCERT? Can you do that for 100 chapters and solve PYQs? No. Okay, so it is just important to focus on the important examples, what we are doing. Remember, in the session that day, Naren sir told 2 classes or topics were divided. So those important heavyweight topics that you should do completely. The other topics, just leave it on us. Just leave it on us. Just do whatever we are doing over here. Okay, Gyan? I hope that is some Gyan for everyone. So this is equals to 300 into 10 to the power 14 upon 58. Now, if this was 50, this would cancel this 6 times. But now I am getting the feel that it would be little bit less than 6. 5 point something into 10 to the power 14, my answer should be there. 5 point something into 10 to the power 14 hertz or second inverse. Is this okay, boys and girls? That is S I have tried to write. It is looking like 8. Please excuse me for not so bad handwriting. It's okay, readable. Okay, boys and girls. Then after this was on the basis of wave theory. The wave theory said that energy coming is continuous. Then after this, who came into picture? Planck-Garu came into picture. Planck-Garu said energy is coming in the form of chinna tiny packets. Dual behavior of light. Remember the name of the 4 experiments. Remember the name of the 4 experiments. This has been asked in JEE Mains last year. 4 experiments which are explained on the basis of quantum theory. What are the 4 experiments? Number 1, black body radiation. Number 2, this thing, spectra of atoms. Last point, spectra of atoms. Number 3, photoelectric effect. Number 3, photoelectric effect. Third one usually people forget. Variation of heat capacity as a function of temperature. Variation of heat capacity of solids. Variation of heat capacity of solids as a function of temperature, right? So make sure that you remember these 4 names. Okay, boys and girls, moving forward. For black body radiation, if anything can come, it will be this graph. Intensity versus lambda graph. Intensity versus lambda graph. Okay. If I increase the temperature, the lambda, first of all, intensity increases for all wavelengths, but the maxima shifts to a lower wavelength. Please remember this graph. If anything has to come, T2 greater than T1, he can ask you. T2 greater than T1, he can ask you. Please, everybody, remember this graph. On increasing the temperature, maxima shifts to a lower wavelength. Moving forward, boys and girls. Photoelectric effect, best example of Planck's quantum theory. One thing you have to remember over here, Ke max is equals to E photon minus phi. Ke max is equals to E photon minus phi. Phi is the work function. And remember the small formulas for E photon. Chinna formulas, ready-made formulas for E photon. If you want in joule, then 2 into 10 to the power minus 25 divided by lambda in meter. This will give you in joule. And if you want in electron volt, I hope everybody knows that electron volt is 1 eV is 1.6 into 10 to the power minus 19 joule. Then you will do 12,400 divided by lambda in angstrom. This will give you in electron volts. This will give you in electron volts, right? So remember these 2 formulas for E photon, some solved examples, and threshold frequency and nu naught and lambda naught definitions also. Nu naught and lambda naught definitions also you should remember, everybody. Now moving forward, we will talk about over here also 2-3 examples are there. Okay, 4 are there, 6, 7, 8, 9. 2 of them I will do, the other 2 you can do on your own. So calculate the energy of 1 mole photons of radiation frequency 5 into 10 to the power 14. This you will do by yourself. How will you do? I will explain to you. You will do h nu, h 6.6 into 10 to the power minus 34 into nu 5 into 10 to the power 14. But this is for 1 photon. You have to calculate for 1 mole. So multiply by 6.02 into 10 to the power 23. If you are a smart person, nobody will, I know you are, nobody will multiply by 6.02, multiply by 6 into 10 to the power 23. You will get the answer in joules. And if you want in kilojoules, divide by 1000. So this one you can do by yourself. 2.7 I will solve for you. Always, as you are, see, NEET exam may never ever forget that you have the advantage of 4 options. Never ever fall in trap for doing the whole calculation. Okay, try to make some smart approximations, particularly if options are far apart from each other. If the options are very, very close to each other, which will happen in 1 or 2 problems, then do the calculation at the end of the exam. Yeah, if time is there, do it. If time is not there, leave it. One question is not going to change your destiny. Na? As a matter of fact, nobody will be, nobody would be able to solve that question. Everybody would be struggling over there. So if any question is asking 2 tough calculations, Avoid it at that moment or try to simplify it. See, how do I do over here? 100-watt bulb, important could be there in NEET 2026, everyone. 100-watt bulb, monochromatic radiation of 400 nanometer. 100 watt means what, everybody? 100 joules per second. Calculate the number of photons emitted per second. So what will I do over here? Total energy emitted by the source is 100 joules in 1 second. What is the energy of one photon? Energy of one photon is 2 into 10 to the power minus 25 upon 400 into 10 to the power minus 9. This is E photon shortcut formula, joule. Pay careful attention to the units. Into number of photons per second, because this is also per second. This is also per second. Be careful with the units. So bhai and behno means brothers and sisters. This becomes 2 by 4 and this is minus 7. Minus 7 will go up minus 18. Minus 25 plus 7 is minus 18 into number of photons per second. This is 2. This is 200. 200 into 10 to the power plus 18 means n is equals to 2 into 10 to the power 20. Check the answer. Check the answer. 2 into 10 to the power 20. Have a look over here. So see how fast you can simplify the calculations. Then after that, boys and girls, 2.8 is DIY, do it yourself problem. Just have a look at it once after the class. Okay. And although you will be having study hours also today in the evening, so you can discuss in that also. It's not as if that 2.9 I will do. Threshold frequency for a metal is 7 into 10 to the power 14. Calculate the kinetic energy emitted when radiation of this frequency hits. So you know that frequency should be greater than threshold frequency. So what do we do over here? KE max, everybody read the question, read the question. Take 2 seconds, try to solve it, everybody. Okay, everyone. So kinetic energy will be equals to h nu minus phi, and phi you know can be written as h nu naught. So here take h common, h is 6.6 into 10 to the power minus 34 and nu minus nu naught. Now what is nu by? Nu is 1 into 15 means 10 into 14 and this is 7 into 14, matlab 10 to the power 14. So this is 10 into 14, this is 7 into 14, nu minus, this is nu naught, this is nu naught. So 10 minus 7 is how much? 3 into 10 to the power 14. Is this okay, everybody? Bas, one line answer, everyone. 6.6 into 3 is 3 6 18, 19.8. 3 6 18, 19.8 into 10 to the power minus 20 joule, which is 1.98 into 10 to the power minus 19 joule. 1.988 into 10 to the power minus 19. So fast you can solve, so fast. Okay, boys and girls? Chalo, 2.8 also, you can have a look at it once, but do it. Do it once. I will explain it to you if you want. Quickly I can explain, don't worry. So let's not leave any stones unturned. No? Okay. So electromagnetic radiation, read it fast, quickly. Read it fast. Electromagnetic radiation of wavelength 300 nanometer falls on a surface. Electrons are emitted with kinetic energy they have given as 1.68 into 10 to the power 5 joule per mole. And he is asking you to calculate phi. So he has given kinetic energy in per mole. So what you should do is, you should calculate the E photon also in joules per mole. For 1 mole, this is for 1 mole, na? So you calculate E photon also. This can be an important concept. You calculate the E photon also for 1 mole. So E photon for 1 mole, 300 nanometer, 2 into 10 to the power minus 25 upon 300 into 10 to the power minus 9. This is in joule for Okati photon. But I want for Okati mole photon. So I am a smart person, you are also a smart person. 6 into 10 to the power 23 we will do. So solve it, and then after that you can use Ke is equals to E photon minus phi, and from there you will get the phi in joule per mole. Okay, from there you will get the phi in joule per mole. You can easily solve that and the value you will get over here. Okay, and then after that he is asking you to calculate the threshold wavelength also. So for that, convert that per mole into, again divide by Na. Okay, that phi you have calculated now. So phi divide by Na over here. See, this is the value of phi that you will get after doing Ke is equals to E photon minus phi. Bring phi here, Ke here, E photon you can calculate like this. This is the value of phi you will get. Then divided by Na. So you will get in joules. And then once you get this value in joules for one electron, okay, phi, then after that, what will you do? This value, once you have got in joules for one, 3.84 into 10 to the power minus 19 is equals to hc by lambda, 2 into 10 to the power minus 5 upon lambda naught. So from here you can calculate the threshold wavelength, or you can do in EV also, but have a look at this problem, okay? Chalo bhai, moving forward. Please, this is quite common sense, everybody should remember. Lyman is in UV, okay, Balmer is in visible, and remaining everything is in infrared. For Balmer, which ones are in visible? This diagram also chala important. First four lines, okay. VBGR, only first four are invisible. Violet, blue, green, red. Please remember VBGR, 622, 522, 322, sorry, 622, 522, 422, 322. VBGR, please remember that, everybody, okay? Then after this, moving forward, next we will look at the examples. Please remember this formula for frequency also. This is important. Important formulas of Bohr model, everybody. Radius of nth orbit, what is the formula? 0.529 into n square by z angstrom. Remember this formula. This is also equals to 52.9 into n square by z picometer. Velocity of electron in a stationary orbit, 2.18 into 10 to the power 6 into z by n meter per second. This 2.18 into 10 to the power 6 meter per second is also equals to c upon 137. Sorry, 2.18 into 10 to the power 6 is also equals to c by 137, where c denotes the speed of light. Remember this as well. Then after this, to another orbit, that is RH into z square into 1 upon chinna square minus 1 upon pedda square. And you can calculate this, use this to calculate wavelength also. For that you will have to take the reciprocal. So when you will take reciprocal, 1 upon RH will come. Remember, it is around 912 angstroms. Around 912 angstroms. RH value you all know, 1.1 into 10 to the power 7 meter inverse. Okay. So we will move on to some of the examples. And energy level diagram of hydrogen atom, chala important. Energy level diagram of hydrogen atom, minus 13.6, minus 3.4, minus 1.51, minus 0.85, minus 0.54, EV. Please remember that. Some of the differences also. 1-2 difference, 10.2, 3-1 difference, 12.1. So please remember these differences, energy level diagram. All right. Chalo bhai, some of the solved examples once again we'll have a look. What is the frequency of the photon emitted during transition from n equal to 5 to n equal to 2? So for this you can straight away, either you can do in terms of energy, or you can straight away use that Bohr's frequency rule, 3.29 into 10 to the power 15 into z square. Okay, so directly you can use, important question everybody, please mark it important, 3.29 into 10 to the power 15, sorry, into z square. Z square is 1 because hydrogen atom is given. 1 upon chinna square minus 1 upon pedda square. 1 upon 2 square minus 1 upon 5 square. Okay, important question. Bohr's frequency rule, remember the formula. Here z square will also come. So if helium will come, then 4, He plus 4 ho jayega ye. Okay? But we are talking about hydrogen, so it will be 1 over here. Now with little bit we can solve this. 3.29 into 10 to the power 15, 3.29 into 10 to the power 15 into 21, 25 minus 4 upon 25 into 4 is 100. This becomes 10 to the power 13. 3.29 into 21 you can solve, not a rocket science. If you want to make an approximate answer, let's take it as 20. So beta, this becomes 32.9 into 2. 32.9 will be 64, 65 something. I'm just doing random. Is 66 something it will come. So 66 into 10 to the power 13 somewhere around get. Are you connecting with me on the mental level, everybody? How am I thinking this? 32 into 64, 66 something. So this is equals to 6.6 into 10 to the power of 14. Everybody, are you connecting on the mental level how I am thinking these answers? Now I will go back. Tell me, online people. Let me have some warm water. Online people, keep responding. Gyan Prakash, thumbs up. Yes, sir. Where are others? Snehita, yes, sir. Excellent. Let's look at the answer. What is the answer by 6.9 into 10 to the power 14? I have calculated 6.6 into 10 to the power 14. I have not done a crime. I have not done a crime. Okay, everybody. Calculate the energy associated with the first orbit of He plus. A first orbit of He plus, they have calculated in joules, but let's say I want to do in EV. So energy in the nth orbit is equals to minus 13.6 into Z square by N square EV. Everybody knows this formula. So energy in the nth orbit will be minus 13.6. Z square is He plus बोल रहा है ना? So He plus Z square is 4, N square is 1 EV. So this will be equals to minus 54.4 EV. If you want in joule, you can put minus 2.18 into 10 to the power minus 18 joules. I hope you know the formula. Radius also, simply you can put the value, calculate the answer, not that difficult. Okay, everybody? And yes, remember those definitions: ionization energy, first excitation energy, second excitation energy, first excited state, which state? First excited state N enta. First excited state N enta bhai, fast cheppu. First excited state, what is the value of N? Cheppu quickly. 2. Please remember that. Very good. Everybody shout in the classroom. I will not ask you, I will ask coordinator ma'ams. Which state is known as the first excited state? If they are able to tell, means you were listening in the class. Okay? All right. So next, after this, we move forward. Everybody, we come to de Broglie-Garou's hypothesis. De Broglie-Garou gave a very important thing, that if light is a wave, shows particle behavior, then particle can also show wave behavior. If A equal to B, then B equal to A. Okay? And lambda of a particle will be given by H by P, which is equals to H upon mv, which will be equals to H upon root over 2m ke. Chinna important formulas. Special formula for electron, root over 150 upon x in angstrom. What is x over here? It is the kinetic energy of electron in ev, ke in ev. Please remember this formula. Please remember this formula. Okay? Special formula only for electron, not for anything else, only for electron. Right, everybody? Chala important formula. Okay. 2.12, you can easily do. Achha, this is significant only for microscopic particles. For macroscopic particles, useless. No point in life. Okay. 2.12, wavelength of ball with mass 0.1 kg and 10 meter per second. Very, very simple. mv will become 1. mv will become 0.1 into 10 is 1 bhai. So lambda will be equal to h. That is 6.6 into 10 to the power minus 34. Okay, problem 2.13. Electron kinetic energy given, find its wavelength. Now they have given a chala lengthy solution. I will not want to do like this. I will do by using the simple formula for electron. Simple formula for electron. How will I do that, everybody? Kinetic energy, first I want to convert it into EV, because this is given in joule, na bhai? So 3 into 10 to the power minus 25 upon 1.6 into 10 to the power minus 19. Ab dekho, this 1.6, I will make it as 1.5. 1.5 into 3 will cancel this 2 times into 10 to the power minus 19 na, sorry, I'm sorry, minus 19, so minus 19 plus 19, this is minus 6 joule, minus 6 joule. After this, boys and girls, I will not do like this, okay? After this, I will do root over 150 upon 2 into 10 to the power minus 6. This is equals to 75. 150 by 2, 75. 75 ka under root will be between 8 and 7. 75 ka under root will be between 8 and 9. 8 and 9, around 8.5 le lete hain, hai na, 8.5. So 8.5 into minus 6 will go up, it will become plus 6. Plus 6 ka under root will become 3. So this is around 8500 angstrom I am getting. 8500 angstrom, which will be equals to 850 nanometer. I hope you can convert angstrom to nanometer. Nanometer chinna unit na. Nanometer is minus 9, angstrom is minus 10. So angstrom ko nanometer mein convert karo. Convert angstrom into nanometer, you will get 850. What is the answer? 896. ठीक है, we have made so many approximations. So many approximations we have made. Acceptable. Nearby answer I am getting. Is this okay by everybody? Okay, next question after this. Important question. This has not appeared in NEET so far. I am expecting this to come anytime soon. If you are lucky, maybe this year only. Okay. Important question, everybody. Please have a look. Find the mass of a photon with wavelength 3.6 angstrom. Wavelength 3.6 angstrom, mass of a photon. This answer is wrong, by the way. This answer is, key correction is there. You can change this value as minus 33. New NCERT, I think this power is wrong. Okay. So you can change the correction over here. So lambda is equals to, important, mass of photon we have to find out. So lambda beta is equals to h upon mv. So m is equals to h upon v into lambda. Please mark this question important. Everybody should do this. Okay. H is equals to 6.6 into 10 to the power of minus 34. V of photon is 3 into 10 to the power 8. Speed of light. Photon travels at speed of light. 3 into 10 to the power 8. And lambda is equals to 3.6 into 10 to the power minus 10. 3.6 into 10 to the power minus 10. So this afterwards you can do the calculation. Okay. This is around 66. You can solve it now. Okay. 66 and 9, 10 to the power. So you can do that. This answer will not match exactly. Okay. If you want to see my calculation skills, I can show off. But I think enough show off we have done. Now let's move further. So this will become 6.6 and this is 10 to the power minus 2. Minus 2 will become 10 to the power of minus 32 and minus 2 will become 10 to the power minus 32. Am I right? Yes. And 3 into 3.6. So 3 into 3.6. Ab 3.6 ka double is 7.2. So this will not be double, little bit less than double, around 1.8. Little bit less than double, around 1.8. And this will cancel this 0.6 times. So 0.6 into minus 32, that is equals to 6 into minus 33. I got the answer. Yeah. 6 into 10 to the power minus 33. Is this okay, boys and girls? Did you realize how am I thinking? Is this okay, everybody, all of you? Chalo, let's move forward. Let's move ahead. Heisenberg principle. Everybody, you understood now how did I perform this calculation? What was going on in my head? Okay, so this is how you have to be mentally present. Chalo, before I move on to Werner Heisenberg, does this photo remind you of somebody? This is a very famous classroom joke which I very often crack. Who does this Werner Heisenberg picture remind you? Sometime back there was a singer from Pakistan who got viral for singing a really stupid song. You all remember that? Aye hi, oe hoye, baddo baddi. So is he not looking like that? Okay, so anyways, so Heisenberg's principle, just remember the equation. Everybody, what is the equation? Delta x into delta p is greater than equals to h upon 4 pi. Remember the shortcut value of h by 4 pi, it is 5.27 into 10 to the power minus 35. Okay, joules into seconds. Joules into seconds, right? So this is the value of h by 4 pi. What kind of questions are there? Delta x would be given, delta p you have to find out, delta p would be given, delta x you have to find out, right? So based on this, 2 questions are there. Just have a look at any one of them, okay, and try to do it. Let's move on to quantum numbers now. Schrodinger equation is there. Read the points. What is psi? Psi tells the wave function, no physical significance. Psi square tells you the probability density of finding the electron at a point, okay. Then after this, these graphs, only these graphs, and this question has come in JEE mains also. Psi of 1s, psi of 2s. So beta 1s does not have any radial node. So 1s में radial node नहीं होता है, does not have a radial node. So graph is like this. 2s has a radial node. So in between, wherever node is there, psi becomes 0 once. So this type of graph you will get for 2s. Okay, this is positive, negative. This is for psi. And if you have to plot for psi square beta, then what will happen? 1s will remain as it is. For 2s, what will happen? For 2s, this negative square cannot be negative, na? Square cannot be negative. So this type of graph you will get. Just remember how to count the number of nodes. Okay, this has been asked in JEE mains. Acha, you will say, ki sir, your graph not matching with this graph, sir. Beta matching. Look where 0 is there. Below 0, it is becoming negative. Na? They have drawn minus 10 at the origin over here. Okay. So be careful about this. Then after this, moving ahead. Quantum numbers is something important. Remember the formula for number of nodes, everybody. I hope you remember. 2 types of nodes are there in the market. Total nodes is n minus 1. Angular nodes is L. Radial nodes is n minus L minus 1. Total nodes n minus 1. Angular nodes L. Radial nodes is n minus L minus 1. Please remember that. Okay, radial node is always a spherical surface. Angular node is generally a planar surface except for dz square. Then after that, moving forward, this is a point waiting to come in NEET anytime soon. Waiting to come in NEET anytime soon if you are lucky enough. For the same subshell, as Z increases, energy decreases. For the same subshell, same subshell, as Z increases, energy decreases. Why, sir? Because of more nuclear charge, the electrons are pulled closer to the nucleus. The closer the electrons are to the nucleus, lesser is the energy. Closer the electrons are to the nucleus, lesser is the energy. So this is a very important point. Any given day it can be asked. Be mindful about this particular thing. Chaliye, moving forward. Okay, exchange energy, JEE main 2024 question or something. 24 or 25, little bit year missing. Okay, that can happen. Remember this question has appeared in your I have seen your papers. It has appeared in one of the PACE or one of your earlier exams, internal exams. It has come. I don't remember whether it was PACE or phase or chase, but this question somebody had given in one of your test papers. So please kindly revise that question. That is a JEE main PYQ. Same JEE main PYQ has been given. There they are asking for the reasons for stability. So please revise that question. If a good question has to come, it can come. Okay. Then in the exercises, my dear kids, some very good questions on quantum numbers are given, which I have circled for you, which you must definitely do. Okay. So some important quantum number questions are given. So you can quickly have a look. I will not be doing all of them. This one you can do. This is a JEE advanced PYQ. Please have a look at it. Solve it definitely. This one 2.10 is a NEET PYQ. 1.2 you can do. 1.3 you can do. 1.5 definitely very important. Maximum number of emission lines, not absorption. Absorption is n-1. Emission lines they are asking. When electron n equal to 6 to ground state. So this question can come. NEET 2026 important question. Maximum number of emission lines when electron in a sample of atom. Generally we will go for sample. So 6 to ground state. So what is the formula? n(n-1/2). So number of energy levels is 6. Or you can say delta n depending upon what form you are using. Okay. One form for this is this one also. Delta n. This is more universal, so you can use this delta n into delta n plus 1 by 2. So what is delta n? 6 to 1. So that is 5. That was also correct, but that will work for ground state only. This will work always. So 5 into 6 by 2, that is equals to 15 lines. 15 lines. This formula, you remember, this is more popular version. Okay. All right. Then after this question also waiting to appear. I think JEE Mains already asked. Which orbital will allow G orbitals? S, P, D, F, G. S, P, D, F, G. So 5S, 5P, you know that number of shells is equals to number of subshells. So if you want 5 subshells, you have to go to n equal to 5. So which will allow G orbitals to exist? Answer is n equal to 5. Then go through the ranges of the quantum numbers as well. Make sure that you have a look. Okay. These questions, how many electrons can have n equal to 4, m equal to minus half? Look at this. N equal to 4, m equal to minus half. Beta, n equal to 4 can have total of 2n square. That is 32 electrons. Out of 32, 16 plus half, 16 minus half. Just try to do as many questions from them. Of course, we don't have the time to solve all of them. N equal to 3, L equal to 0 means 3s. 3s will have rundu electrons. 3s will have rundu electrons. So this is 16 and this is 2. This is 16 and this is 2, right? Okay, moving forward, these are the questions which you can have a look. And yes, this same question we have done. N equal to 4 and S equal to minus half. So that completes our everybody. You can clap. Atomic structure revision also. Pay special attention to quantum numbers. Do lots of questions. Which quantum number is possible? Arrange in order of energy. Okay, I hope you have circled along with me. I hope you have circled along with me. This one also you can do. Which quantum number is possible, which is not possible. So make sure you revise it nicely. They are all important models. Next, I will move forward and we will come to the next chapter, boys and girls. That is your 1 minute. So, and see this done. Next, we will revise. Let's do thermodynamics first of all. Thermodynamics, okay? Let's do thermodynamics. One minute. What problem happened, bhai? Again, I have to struggle for 2 minutes, but I don't have time. Okay, we'll do from here only. Thermodynamics, no? Okay. One minute, thermodynamics. Why is it not coming here? Okay, nice. Okay, very good. So boys and girls, let's come to thermodynamics. Is everybody ready, all of you? Online people, please confirm. Everyone ready for thermodynamics? Again, very important chapter. Okay, very good. So, thermodynamics, we will look at the most important things over here. Let's have a look. So first of all, this is a very simple question. Okay, where they are talking about open system, closed system. What is first law of thermodynamics? It is simply a law of conservation of energy. It is simply a law of conservation of energy, right? And it is applicable in a closed system. You should remember that it is only applicable in a closed system. What is a closed system? Where matter will not be exchanged, only energy will be exchanged. Only energy will be exchanged, right? Okay, then after this, so this question you can have a look later on. Then after this we come to this solved example. This is an important one, problem 5.2. 2 liters of an ideal gas expand at a pressure of 10 atm isothermally into vacuum until its total volume is 10 liters. Isothermal process into vacuum. So this is an example of free expansion, everybody. W is equals to minus P external into delta V. Now vacuum means P external equal to sunna. So P external equal to sunna, so W also equal to sunna. And ideal gas ideal gas internal energy only depends on temperature. For ideal gas, internal energy depends only on temperature, right everybody? So delta U is equals to 0. Delta U is equals to 0 for ideal gas. Okay? Delta U is equals to 0 because isothermal process. Whenever isothermal process is there, for an ideal gas, delta U will become how much, everybody? 0. Delta U will become 0 for ideal gas in isothermal process, right? Then after this, second part is how much heat is absorbed and how much work is done in the expansion. How much heat is absorbed? And so, beta delta U is 0, W is 0. So Q is also equals to 0, na? Q is also equals to 0. Then after this, we come to problem 5.3, same expansion, but against external pressure of 1 atm. So W will be equals to minus P external 1 atm into delta V. Delta V is how much? 2 to 10. 2 liters to 10 liters. So that is 8 liter. 8 liter, right? So your W is equals to how much, everybody? Minus 8 liter atm. Minus 8 liter atm in liter atm. If you want in joule, remember 1 liter atm is approximately 101.3, approximately 100. Exactly 101.3, approximately 100. So around minus 800 joule you will get your answer. Ideal gas isothermal process, delta U will be 0. Delta U will be 0 without any doubt. So delta U is 0, so delta U is Q plus W. And delta U is sunna beta because constant temperature ideal gas. So Q is equals to how much? Q is equals to minus W. So W you have calculated plus 800 joule, you will get the answer. This is for irreversible process. If I have a reversible process, look at problem 5.4, everyone. Look at problem 5.4, right? Consider the expansion if it was conducted reversibly. V2 by V1 and all that, okay? So 2 minutes break for battery changing. So I hope you have done this problem. We simply have to apply the relation of which one over here? Pen ikda. Okay. So over here we have to apply the reversible isothermal formula. So reversible isothermal formula, everybody, is minus 2.303, which smart people will take as minus 2.3 into nRT. N is how much? Find how much? 1 mole of ideal gas. So N is 1. N is 1. R value I will take as, if I want the answer in joule usually, so 25 by 3, and temperature is given as 25 minus N 2.3 nRT. Temperature is given as 298 Kelvin, but smart people like you and me always take 300, okay, into log of V2 by V1 or P1 by P2, whatever is the case. So V2 by V1 is log 5, 10 upon 2. So 10 upon 2 log 5 enta 0.7. So bhai, this will cancel out 100 times. And now I think this is not that difficult calculation. You can easily perform it. Very cute calculation is there. Little bit time, 4 marks it is going to give you. So you must invest that much of time. You must not be in a hurry. So solve it. Ignore the NCERT answer. They have calculated in liter ATM. If you want in liter ATM, then also no harm. Put this value in liter ATM. 1 by 12. If you want in calorie, put this R in calorie. So up to you. Depends upon that. Then after this we come to enthalpy. What is the difference between delta H and delta U is heat at constant volume, and delta H is heat at constant pressure. This is the important difference. This is extremely important from chemistry point of view, because most of the processes in chemistry are constant pressure processes, and constant pressure heating and constant volume heating will be different if gases are there. Chala important point, please underline. If solid and liquid are there, because solids and liquid do not expand or contract too much, their delta H and delta U are almost same. Delta H and delta U are almost same. Significant difference is not there. Then we come to the, the relation between H and U, different cases are there. Beta H is equals to U plus PV. Okay. Now, if you have an ideal gas non-reacting. Ideal gas non-reacting means no reaction, nothing. Then you use number of moles will be constant. Then delta H is equals to delta U plus, in place of PV you can put nRT, and over here N is constant, so nR delta T you will do. For non-reacting ideal gas. Understood everyone? But if it is a reacting ideal gas, some chemical reaction is there where gases are there, then temperature would be constant. For chemical reaction where gases are there, temperature would be constant, but moles of gas will change. So you will get delta H is equals to delta U plus delta NGRT. Chala important relation for NEET point of view. For chemical reaction, where is it valid? This is valid for non-reacting ideal gas where temperature is changing. This is valid for chemical reactions and phase transformation where temperature is constant but number of moles of gas is changing. Very, very important. 2-3 questions are given. One of them I am going to do. Based on this is important, boys and girls. Okay. So now I will come to problem number 5.5. Water vapor is assumed to be a perfect gas. Molar enthalpy change for vaporization of 1 mole of water at 1 bar and 100 degrees centigrade is 41 kilojoule per mole. So delta H they have given. Calculate the internal energy change. Delta U I have to find out. What is the process? Process is 1 mole of liquid water is vaporized. That is H2O liquid. 1 mole going to H2O gas, 1 mole. This is the process. Okay. So simply over here, 41 kilojoule is delta H. Delta U I have to, with this relation, everybody is applicable for phase transformation and chemical reaction. So delta H is equals to delta U plus delta NG delta Ng moles of gas only, and liquid solid not taken beta. So delta Ng1, R value 25/3 joules. Temperature enta 373. But this is joule, this is kilojoule. Do not forget to divide this by 1000. Don't forget to divide by 1000. Okay, everybody. So from here you can calculate the delta U value. This value, let's try to quickly figure out how much this will be. This will be 3 1s are 3, 3 2s are 6, 13. So 13 means 4s are 12. So 124 के around आ रहा है ना? And 25 will cancel this how many times? This will cancel this 25 40 times. 43s are 120, around 3 it is coming. So beta delta U will be 41 minus 3, that is equals to 38 kilojoule per mole. Let's check the answer, 37.9404 kilojoule per mole. Is this understood or not, everybody, all of you? Okay. So please remember, this will be valid for chemical reaction and phase transformation taking place at constant temperature. And although chemical reactions and phase transformations occur at constant temperature, but heat is absorbed or released. Don't say that, sir, isothermal you told delta H 0, delta U 0. Bhai, I told that for non-reacting ideal gas. For non-reacting ideal gas, if very huge misconception, people all over the country from Kashmir to Kanyakumari have this. Ki isothermal means delta H sunna, delta U sunna. No. Isothermal for non-reacting ideal gas means delta H sunna and delta U, only for non-reacting ideal gas. Chemical reaction takes place at constant temperature. Phase transformation, ice melts at 0 to form water at 0. Water evaporates at 100 to form steam at 100. Is it not absorbing heat? Of course it is absorbing heat. That is known as latent heat. So for chemical reactions and phase transformations, please use this. That logic equal to sunna which came in the first example was only for ideal gas. Do not forget this very important concept. Moving forward, intensive, extensive, everybody knows. Bohm calorimeter, important. Bohm calorimeter is a constant volume device. Remember that. Bohm calorimeter is a constant volume device, boys and girls. Problem number 5.6 we will see. So if Bohm calorimeter is a constant volume device, then the Q which you measure from there is what? QV. Q which you measure from there is QV. Do not forget that it is a constant volume device. Let's have a look. Problem 5.6. 1 gram of graphite is burnt in a Bohm calorimeter in excess of oxygen at 298 Kelvin and 1 atm according to the equation. This is the equation. Okay. During the reaction, temperature rises from this to this. If heat capacity of the Bohm calorimeter is this much, what is the enthalpy change for the above reaction? Okay. So over here, I have to find the enthalpy change for the reaction. Carbon graphite plus O2 goes to CO2 gas. 1 gram of carbon I have taken. 1 gram of carbon I have taken and I have burnt it. And because of that, heat is released. Who absorbed that heat? Calorimeter. Calorimeter means water and all absorb that heat. Temperature increased from 298 to 299. So beta, how much heat was released? Q released is equals to C total, that is the total heat capacity, into delta T. So C total is how much, everyone? Tell me quickly. Twarga cheppu. 20.7 kilojoule per Kelvin. And delta T enta 298 to 299, that is equals to 1. So 20.7 kilojoule of heat was released by 1 gram of carbon under constant volume. I have to find delta U. So delta U I have to find by 1 mole. Na? So delta U will be equals to minus C total into delta T, minus C total into delta T, divided by W, that is the mass that I have taken, which in this case is 1 gram. So I don't need to divide, but in general, if 4 gram is here, so you will divide by 4. If 5 gram is here, you will divide by 5. Then you will get per gram into the molecular weight of the substance, which for carbon is how much? 12. You can ask, sir, why minus sign over here, sir? Why minus sign? Yes, Sarla, I will do that. Don't worry, everything. Minus sign over here, sir, because it is heat released. Because this is heat released. Okay, this is heat released. So now you can put the things over here, everyone. So you will be getting minus 20.7 by 1 into 12. So this will come out minus 20.7 into 12. You can have a look at it. So how much does this come? I am just saving some of your time. 12 sevens are 84, 12 twos are 24. So minus 248.4 kilojoule per mole is coming. Minus 248.4 kilojoule per mole is coming. Is this okay? But Bohm calorimeter is a constant volume device. Bohm calorimeter is a constant volume device, and this is delta U only. What about delta H? For delta H, boys and girls, I have to apply delta H is equals to delta U plus delta NGRT, and in general I have to solve like this. But since in this question we are lucky enough that delta Ng equal to sunna, so delta H will be equal to delta U. Delta H will be equal to delta U. Okay. Now, boys and girls, next we come to this thing, that is thermochemistry portion. So thermochemistry, remember 2-3 things. Definition of all the enthalpies, enthalpy of formation, enthalpy of combustion. Okay. Enthalpy of formation, these kind of questions are very common. 4 equations would be given. Which of the following is enthalpy of formation? Which is not enthalpy of formation? So you should have, what are the things you have to check? That compound should be 1 mole and we should have element in reference state. Like for example, if I come over here, enthalpy of formation. So yes, so enthalpy of formation, look at some of the examples. Okay. So this reaction, 1 mole H2O from element in reference state, this is enthalpy of formation. But this reaction, okay, this is exemplar example also, this is not enthalpy of formation. Why? Because CaO and CO2 are not element in reference state. They are not element in reference state. Then for element in reference state, delta HF naught for element in reference state. Okay, reference state is that state where the element enthalpy of formation is taken as 0. So some of the important ones which people generally miss: iodine is solid, bromine is liquid, F2 and Cl2 are what? Gas and gas. These are reference state for halogens. Sometimes allotrope also needed. Carbon, graphite is the allotrope. Sulfur, rhombic is the allotrope. Rhombic sulfur is the allotrope. Phosphorus, white phosphorus is the allotrope. So these are all the reference state where the enthalpy of formation is 0. And you have to find, for this enthalpy of formation is 0, so you have to keep this in mind. And if you have to find whether the reaction is correct for enthalpy of formation or not, you have to see 1 mole product from element in reference state. Like this is 1 mole, but element is in not reference state. Similarly, this is also element in reference state. This is element in reference state. Focus, focus, focus. Important point. This is element in reference state, but 2 moles is there. So these kind of questions, chala important. Then after this, beta, you have key enthalpy of formation would be given, and you will have to find delta H of the reaction. So if formation is given, then delta H naught of the reaction is formation of PDTS, total formation of products, minus total formation of reactants. If I know formation data for everything, if I know combustion data for everything, then we do combustion of reactant minus combustion of product. Reactant minus product we do for combustion. And in terms of bond energy, but everything should be gas. Everything should be gas. All reactant products should be gas. Then only we do bond energy of total reactants minus total bond energy of products. So these are 2-3 shortcuts of thermochemistry. Kindly remember them. All right. So this is the example over here. You can have a look at it. Then after this, boys and girls, we move ahead. Next definition is what is this given over here? Per mole of reaction means when the reaction takes place as per the given stoichiometry. Okay, have a look at this paragraph. This could be something. I mean, this is little bit important. Then after this we come to some important definitions, Hess law and all. Everybody, whether you hold your nose like this or whether you hold your nose like this, eventually you are holding your nose. So enthalpy is also like that. Okay, so this is Hess law. Then problem number combustion. Problem number 5.9. We will just read it out. Okay, simple problem, not that difficult. Combustion of 1 mole of benzene takes place at this temperature. After combustion, CO2 and H2O are formed, and this much heat is liberated. Standard enthalpy of formation is given. So write down the combustion for benzene. Okay, so benzene is in liquid state. I think they have given. Benzene is liquid usually. In solutions chapter also we study. C6H6 liquid plus O2 gas goes to what, everybody? It goes to 6 CO2 gas, 6 CO2 gas. Okay, just a minute. 6 CO2 gas plus how much is hydrogen over here? 3 H2O liquid. And here I will have 15 by 2. So this is the combustion of benzene. 1 mole of benzene combusted. Now beta, what is the delta H for this reaction given? Okay, we will not follow the NCERT solution. Chala lengthy, time wasting. Okay, focus on the concept. So what is the delta H of this reaction? Minus 3267. Delta H is minus 3267. I know the delta H for this. And delta H for any reaction can be written as total formation of product minus total formation of reactant. CO2 formation and the CO2 formation minus 393. So 6 mole CO2, 6 into minus 393.5 plus 3 mole H2O, 3 into minus 285.3. This is total formation of products minus total formation of reactant. So reactant is benzene. I have to find, that is X, O2 equal to 0 because O2 is element in reference state. Just I will solve this equation. I will get X from here. What rubbish they are trying to do, I have never bothered to read this part. Okay, ignore this. Then some important points beta. Enthalpy of atomization is when 1 mole of a substance, 1 mole of a substance is converted, any substance is converted into its gaseous form. Enthalpy of atomization is when 1 mole, enthalpy of atomization is when 1 mole of any substance is converted into its gaseous atoms, not gaseous form, gaseous atoms. Okay. So 1 mole of substance is converted into gaseous atoms. So what will happen over here? Let's have a look, everybody, quickly. So let's have a look at some of the examples of enthalpy of atomization, everybody. Thermochemistry, really important topic. So look over here. CH4 gas converted into C gas plus 4H gas. This is equals to, this is enthalpy of atomization. This is also equals to 4 times bond enthalpy of CH bond, because 4 moles CH bonds are being broken. This is enthalpy of atomization of H2. This is also equals to HH bond enthalpy. 1 mole HH bond is broken. This is enthalpy of atomization of Na solid. This is also equals to enthalpy of sublimation, because you know this is sublimation. So 3 very important examples I have covered. Okay. Then after this, in your gym also some solved examples are given for difference of bond dissociation enthalpy and bond enthalpy. Okay. So I think over here, yes, this is the best example to understand. Bond dissociation enthalpy is the specific value. Like if you look at CH4 molecule, so CH4 molecule beta, 4 CH bond. If you break them one by one, then this value 427, 439, 452, 347 needed, right? So these are for first bond, second bond, third bond, fourth bond. If you take the average of all of them, okay, then you will get the mean bond enthalpy, which is simply known as bond enthalpy. So once again, everybody, what is bond enthalpy? It is what is bond dissociation enthalpy? It is the specific value. And what is bond enthalpy? It is the average value. Average of all the four things. Okay, 4 bonds, 3 bonds, whatever are there. And then after this part I have already discussed with you previously. I have explained this to you, right? That whenever we are doing in terms of bond enthalpy, we do reactant minus product. Then this is Bohr-Haber cycle, nothing very special about it. Next after this, yes, this could be a question in NEET exam. Okay, that enthalpy of solution, particularly for NaCl, if they have to ask, very, very important. Enthalpy of solution, okay, is equals to delta H naught lattice enthalpy plus delta H naught hydration enthalpy. Lattice enthalpy is positive value, hydration enthalpy is negative value. Overall value can be positive or negative, but mostly for ionic compounds it is positive. Mostly for ionic compounds it is positive. Okay. Thermochemistry in this part, it's one of the most important topics, I would say. And remember this lattice enthalpy and hydration enthalpy, particularly this example of NaCl, very, very important. You can see for NaCl 788 and minus 784 given, plus 4 is coming over here. Okay. Then from here, some of the Bohr-Haber cycle, so I hope everybody knows how to draw it. Not that important, you can still have a look. Bond dissociation and bond enthalpy we have discussed most of the important points. Let us come to the second law, and then after that we will come to the some of the important questions in the exercises. Thermodynamics, some really very important questions are present in the exercises. Okay, so we will have a look. Yes, now let us come to the second law. So second law beta gives us what? Second law gives us the condition for spontaneity. It gives us the condition for spontaneity in terms of delta S total. If delta S total is greater than 0, if delta S total is greater than 0, that is equals to, and how do we calculate the delta S total? This is equals to delta S system plus delta S surrounding. Delta S system plus delta S surrounding. Okay, so this delta S total, everybody, should be greater than 0 for a process to be spontaneous. If this is greater than 0, then we say that the process is spontaneous. This is the criteria for spontaneity. And what is entropy? I hope everybody knows that entropy is nothing but a measure of randomness or disorder. This question, although previously asked in NEET, but still a very, very important problem. Very important problem. Predict in which of the following. Entropy is what, everybody? Measurement of randomness or disorder. Very important problem. Pay attention, all of you. Predict in which of the following entropy increases or decreases. Liquid crystallizes into a solid. So liquid is having more disorder. Liquid is going to a solid. Of course, what? Entropy is decreasing in this case. Solid has less disorder. Temperature of a crystalline solid is raised from 0 to 115. Whenever you raise the temperature of anything, or whenever you raise the volume of anything, please remember entropy increases. TVSI, temperature, volume increase, entropy also increase. But remember, this point is also mentioned in NCERT over here. On increasing temperature, entropy increases, but delta S decreases, because delta S is equals to Q by T, na bhai? So if you increase the temperature, entropy will increase, but delta S will decrease. That is at higher temperature, entropy will increase by a lesser amount. Very, very important point. Read over here. The temperature is a measure of average chaotic motion of particles in the system. Heat added to a system at lower temperature. Heat added to a system at lower temperature causes greater randomness, means more increase in entropy than when it is added at a higher temperature. This suggests that entropy change is inversely proportional to the temperature. Delta S is related with Q and T for a reversible reaction as given. This Q by T is given over here, Q reversible by T. So please make a note of this. Here for chemical reactions, beta, how do we judge for entropy? Again, very, very important. 1 second, break for water. So here again, once again, for chemical reactions, beta, what do we have to check? We have to check delta Ng should be greater than 0. If delta Ng is greater than 0, means number of moles of gas is increasing. So you can see over here. Here you have delta Ng for the third reaction. Delta Ng is equals to 2, na? 1 plus 1, 2, and here you have nothing. And for this reaction, delta Ng is equals to how much? 1. Okay, 2 minus 1. So if delta Ng is greater than 0, then entropy would increase. And of course, if it is less than 0, then entropy would decrease. If it is less than 0, then entropy would decrease. All right, let's move ahead. So all the examples we have done. And next after this, let us come to problem number 5.11. What you were asking, Sarla, okay? Somebody in the chat box mentioned 5.11. For the oxidation of iron, this is the reaction given. Entropy change is minus 549.4 joule per Kelvin mole. In spite of negative energy, in spite of negative entropy change, why is the reaction spontaneous? This is rusting of iron basically. And this reaction is rusting of iron, na? So in rusting of iron, entropy change is negative. Delta S is negative. But still he is saying that reaction is spontaneous. Why? Because this is only delta S system. Criteria for spontaneity is delta S total, system plus surrounding, everybody, okay? And how do we calculate delta S surrounding? Rusting of iron is a spontaneous process, it occurs on its own. Delta S surrounding is equals to minus Q by T. This Q is the Q of the system, which you calculate from FLOT. And what is given to us? Delta H is given to us. So delta H is QP only, na? Delta H is QP. So beta, delta S surrounding will become minus of this quantity. So 1648 into 10 to the power 3 minus of minus 1648. So 1648 into 10 to the power 3 upon temperature is how much? 298, but smart people will take it as 300. Is this understood? So you will do this, you will get this value. This is your delta S surrounding. Solve it, you can do that. And now you will go for delta S total, which is, this is surrounding and this is system. And system plus surrounding will give you this value. Then boys and girls, after this, we come to the 4 cases of very, very important, chala important, Gibbs free energy, super duper, ultra pro max important. So that point we will revise quickly. So delta G is equals to delta H minus T delta S. Okay. Here 4 different cases are there. What are the 4 cases? Delta H, delta S. Delta H, delta S. Okay, everybody? Delta H negative, delta S positive. So this is negative, this is positive. So always negative. This is a blessing from God. This is always spontaneous. This is always spontaneous. Okay. This is always spontaneous. Then after this, number 2 we will discuss delta H positive, delta S negative. So positive, this is negative, so this also becomes positive. This is always, this is a curse from God. This is a curse from God. This is always non-spontaneous. Non-spontaneous, everybody. Case 3 is both are negative. Both are negative. Case 3, chalo, let's take both are positive. Lete hain pehle, chalo, hai na? Both are positive. So both are positive. This is also positive. This is also positive. So this will become negative. So positive, 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 spontaneous at high temperature. Positive, positive, high. Negative, negative, low. Remember like that. Positive, positive, spontaneous at high temperature. Negative, negative, spontaneous at low temperature. Negative, negative, low temperature. Everybody, please remember that, all of you. Okay, positive, positive, high, negative, negative, low. And finally, the next thing is that over here we can calculate the equilibrium temperature also. So equilibrium temperature, how do we calculate? By putting delta G equal to 0. So if you put delta G equal to 0, T equilibrium is equals to how much, everyone? Delta H upon delta S. it is spontaneous for T greater than T equilibrium. This is spontaneous for T less than T equilibrium. And how do we calculate the equilibrium temperature? By putting delta G 0. So you get T equilibrium is delta H by delta S. So these are the 4 cases of Gibbs free energy, everybody. Keep watching, keep watching. Okay. So all this is done. Then after this, these are the all the cases which I have discussed with you. Very, very important. These are few questions related to that relation. They become important in electrochemistry, not over here. What is that relation, everybody? Delta G naught is equals to minus 2.303 RT log of K. Delta G naught is minus 2.303 RT log of K, everybody. This is the relation. Okay. So maybe if you want this question you can do, or any one, up to you. Okay. That phosphorylation question, where is that? Phosphorylation. Achha, I think it is in chemical equilibrium chapter. So maybe 1 or 2 examples of this we will have a look in chemical equilibrium chapter. Okay. So this is just taking delta G and all. Then after this, beta, some of the important questions which you must do, all the objectives you must definitely do over here. All the objectives, please circle them. Definitely you must do. Okay. Like 5.4, I will very quickly discuss with you, everybody. Delta U naught for combustion of methane. So combustion of methane, 5.4, remaining are simple, you can try it. 5.4 I will discuss. Okay. Combustion of methane. Now combustion of methane will be what, everybody? CH4 gas plus 2O2 gas. First 4 hydrocarbons are gases, that is why CH4 I have written as gas. Okay. Goes to CO2 gas plus 2H2O liquid. Sir, why did you write H2O as liquid? Beta, it is at no temperature is given, so I can consider room temperature. At room temperature, water will be a liquid. Okay. So delta U is given and delta H they are asking me. I know that delta H minus delta U for a chemical reaction is equals to delta Ng RT. Now what is delta Ng over here, boys and girls? Everybody tell me. Delta Ng is equals to 1. This will not be considered. Remember that. 1 minus 3. So 1 minus 3 is equals to minus of 2. Minus of 2. And if delta minus 2 is negative, if delta Ng is negative, then delta H is less than delta U. Delta H is less than delta U if delta Ng is negative. And if delta Ng is positive, then delta H is greater than delta U. So please remember this. This could be, if you are lucky enough, this could be a probable question in your upcoming NEET exam, right? So what will be our answer for this? Negative. So value of delta H is less than delta U naught. Okay. Rest these questions you must definitely do. 5.6 also we can see. A plus B goes to C plus D plus Q. Plus Q means what? Heat is released. Means delta H is negative. Positive entropy change means delta S is positive. So delta H negative, delta S positive. This becomes the first case, na? Blessing from God. So this is possible at any temperature. Although this question has appeared in NEET once. This question has appeared in NEET once. Okay. Next after this, enthalpy of formation of methane you have to find. Enthalpy of formation of methane. So I'm just orally telling you this one. Orally telling you this one. So what will be the reaction? C plus 2H2, C graphite plus 2H2 goes to CH4. This reaction represents enthalpy of formation of methane. And now what has been given to me? Combustion data is given. Combustion data is given. So I know combustion of methane. I know combustion of graphite. I know hydrogen. What is my reaction? C plus 2H2 goes to CH4. So combustion data has been given. So total reactants minus total products. So everybody, you know combustion, total combustion of reactant minus products do, you will get the answer. Make sure, boys and girls, you are doing these circled questions. This one also you can try. This one also I'll tell you a beautiful way of this. Okay, a point which many people usually miss. I have to find standard enthalpy of formation of CH3OH. What will be the reaction? Carbon graphite plus half O2 gas plus 2 H2 gas. 1 mole of substance formed from element in the reference states goes to CH3OH liquid. Okay, this is my target equation. For this reaction, I have to find out the enthalpy of the enthalpy change. The enthalpy change of this reaction will be called as enthalpy of formation of CH3OH liquid. Now, how most people will do this problem is that they will try to get this equation with the help of these equations using Hess law. This is how in general many people approach this. But boys and girls, if you observe carefully, 1 mole of methanol combusted, this is nothing but minus 726 is nothing but enthalpy of combustion of methanol. Minus 393 is nothing but enthalpy of combustion of carbon graphite. And minus 286 is nothing but enthalpy of combustion of hydrogen. So my dear bachcho, minus 393 is enthalpy of combustion of carbon. Minus 286 is enthalpy of combustion of hydrogen. Minus 726 is enthalpy of combustion of methanol. And O2 causes combustion. O2 does not undergo combustion. Enthalpy of combustion sunna. So I know everything for in terms of combustion. So I will do total reactant minus total product. So bhai C ka value is how much? Minus 393 plus 2 into minus 286 minus 726. One line will give you the answer. So please try to approach the problems in this manner. This is extremely important. Then 5.16 important but already asked in need. 5.17 you should do. 5.19 also you can do. And lastly we will come to this 5.22. This question also you can do. Entropy change when 1 mole of H2O is formed under standard conditions. So when 1 mole of H2O is entropy change of the surrounding. So beta delta S surrounding is equals to minus Q by T. Delta S surrounding is equals to minus Q by T. Minus Q by T. Right? And what is Q over here? Minus 286. So minus 286, that is plus 286. And surrounding temperature is not mentioned. Take it as 25 degrees centigrade, that is around 300 Kelvin. Around 300 Kelvin into 1000 also you can do if you want in joules. All right, bhai, everybody. So that completes thermodynamics. That completes thermodynamics. Let's go back. So thermodynamics, I think basic important points from NCERT, everything is covered. Next chapter, are you ready, everyone? Next chapter, everybody is ready? All of you? Tell me, Cheppu fast. Next chapter, everyone. Okay, very good, very good, very good. So next after this, let us pick up a smaller chapter. Thermodynamics was also quite, you can say, calculation intensive. Let's pick a slightly smaller chapter, redox, and then we will come to equilibrium. Equilibrium is also calculated. Chalo, let's do equilibrium first. Which one you want to do? Redox first or equilibrium first? Redox or equilibrium? Everybody. Just give me a minute. Let's do redox first because we are almost out of time now. So maybe equilibrium very quickly. Early morning tomorrow we will cover. Okay. Tomorrow early morning we will cover equilibrium. Let's cover redox first, everybody. Okay. Redox is also an important chapter. Okay, everyone. So let us come to redox reactions. Again, a very important, but no calculation over here. Theoretical chapter only. So important portions over here, boys and girls. First of all, in the reaction given below, identify the species undergoing oxidation or reduction. So how do you identify? Beta, increase in oxidation number, loss of electrons is oxidation. Decrease in oxidation number, gain of electrons is reduction. So let's come to this. Here what is happening? Look over here. Very common type of question. Cl2 going from 0 to -1. So this is decrease, reduction. Sulfur going from -2 to 0. So this is increase, oxidation. So like this you can do. Similarly, over here, third one you can try, second one you can try by yourself. Aluminium going from 0 to +3, oxidation. And Fe3O4, iron going from oxidation number, I hope everyone knows to calculate, 8/3 to 0. So plus 8/3 to 0 is decrease, reduction. So like this you can do oxidation, reduction, who is going what. Then after this, we come to justify that the reaction is a redox reaction. 7.2 everybody. So how do we check that? 7.2 is a redox because change in oxidation number is happening. So Na is 0, it is going to +1, so that is why it is a redox reaction. Hydrogen is 0, it is going to -1, that is why it is a redox reaction. Okay. Next, this is related to electrochemistry. So this Saurabh Pansar will definitely be doing electrochemistry today, so he'll do it over there. Then after this we move ahead, and rules for oxidation number I hope everybody knows. Let's have a look at the solved examples. So this one you can have a look. This is just about finding the oxidation numbers. So maybe one of them if I do for you, HAuCl4. So HAuCl4 mein beta, hydrogen is +1, okay, and chlorine is how much? -1 in surrounding. These are some typical ones which I am doing. Remaining are direct. You can do that. But this is oxygen -2, oxygen -2. So these ones you can easily do. CuI also iodine -1, copper +1. So this is HAuCl4. This is basically an acid. Okay, H plus AuCl4 minus. So here you have +1. So 1 plus Au is X, -4 equal to 0. X is equals to +3. X is equals to +3 over here, right? So this is HAuCl4. Then I will move on to the more important questions. The four type of redox reactions. The 4 type of redox reactions. Number 1 is combination, when 2 or more things are combining to form a product. And they will ask you questions like this, which of the following is redox, which is not redox. So remember, in a combination reaction, if you find elemental things over here, any one of the reactant is elemental, then usually it will be a redox reaction. If any one is elemental, then it will usually be a redox reaction. Like these are all, look, this is both elemental. Over here what is happening? Both elemental, oxygen elemental. Then decomposition mein, reaction mein, you have A goes to B plus C. And over there, if any one of the products is elemental, then it will be usually a redox reaction. So look over here, okay. For a redox reaction, basically change in oxidation number should be there, that's it. Then we have displacement redox reaction, and then we have disproportionation redox reaction. What is disproportionation by everyone? Disproportionation is when oxidation number of the same element increases or decreases. Same element increases or decreases, okay. Over here, this is an important point. If you are lucky enough, you can, this can be asked. What is the important point over here? Among the halogens, the oxidizing power, you will study this in P block and electrochemistry also, is F2 greater than Cl2 greater than Br2 greater than I2. F2 is a very popular oxidizing agent. Okay, I mean, sorry, very powerful, not popular, I am sorry. It's a very powerful oxidizing agent. Okay. So what you can do is, using a lighter halogen, you can oxidize a heavier halide. So F2 can oxidize Cl minus, Br minus, I minus into Cl2, Br2, I2. Cl2 can oxidize Br minus I minus into Br2I2 and so on. But this reaction is usually not carried out, because usually we carry out reactions in aqueous solution. This is an important point, hai na? This could be asked. Usually we carry out the reactions in aqueous solutions, but if you use F2 to carry out the reaction, kids pay attention everyone, important. If you use F2 to carry out the reaction, then that F2 can oxidize the water also. It is such a powerful oxidizing agent. So read, this implies that fluorine is so reactive that it can replace chloride, bromide and iodide in solution. In fact, fluorine is so reactive that it attacks water and displaces the oxygen of water. It is for this reaction that the displacement reactions of chlorine, bromine and iodine are generally not carried out in aqueous solution. Assertion, reason, okay? Could be asked, okay? And thank me later if it is asked. Thank Sri Gosalites, not me. I mean, I'm also up, because if you thank me, then Gosalites, then I'm all thanked by default. Okay, then after this, one more important critical point over here, that see, in that electrochemical series, just as an exception, this would be a very good question, not a normal question. But remember, in that electrochemical series, which we study in electrochemistry chapter also, over there we say that F2 is the most powerful oxidizing agent, okay? And therefore we say that if you want to convert F minus to F2, there is only one way, that is electrolytically. But remember, there is one more oxidizing agent. You will find this in the appendix at the end. One more oxidizing agent is there, perzenic acid, H4XeO6. H4XeO6, which is more powerful than F2. So in general, F2 is one of the most powerful, but perzenic acid, H4XeO6, is more powerful than F2. This you will find in the appendix given at the bottom, and proof of this is also present in one of the NCERT exercise questions. I will show that question to you very quickly, okay? Proof of this is present in one of the NCERT exercise questions as well. Have a look at this, everybody. Okay, why does the following reaction occur? Perxenate anion is oxidizing F minus into F2. Perxenate anion is oxidizing F minus into F2. So that line which they have written originally, that F minus is converted to F2 only electrolytically, that is at a commercial level. Commercial mein bhai, money becomes important, na, paisa. So we don't want to spend money. So this is an expensive compound. So at the commercial level, that reaction is important. But you have a source by which F minus can be oxidized into F2 using perzenic acid. Okay. Then boys and girls, disproportionation. What happens in disproportionation? Everybody knows. Same element, oxidation, reduction. These kind of questions are very common. Where which of the following is disproportionation? One very common example of this, which looks like disproportionation but is not, is the D block reaction of KMnO4, thermal decomposition. So KMnO4 upon decomposition on thermal heating, I forgot the temperature, around 500 something is there. It forms K2MnO4 plus MnO2. You can check from NCERT once. Okay. So over here, manganese is going from +7 to +6 to +4. Ab this is both reduction and reduction. So this is disproportionation ledu. This is disproportionation ledu. Very, very common example, which is not a disproportionation. Disproportionation means same element should undergo oxidation as well as reduction. Like Cl2 in basic medium, very famous example, goes to Cl minus plus ClO minus, 0 to -1 and +1. You can calculate the oxidation numbers, I hope. So beta, what is this? Reduction. Reduction. What is this? Oxidation for the same element. That is why disproportionation. Then some things which never go disproportionation, F2 does not undergo disproportionation, because F2 can show oxidation state only 0 and -1, 0 in elemental state and -1 in compound. Alkali metal, alkali earth metal, they also never undergo disproportionation. Why? For disproportionation, minimum 3 oxidation states should be there, na? It should be present in intermediate. What is the condition? it should be present in intermediate. From there it should go up as well as go down. So for this to happen, at least 3 different oxidation states should be there. But fluorine is not given this gift by nature. Fluorine is always either 0 in elemental state or -1. Sodium is either 0 or +1. Magnesium is either 0 or +2. So these are some of the things which cannot disproportionate. Problem 7.5, my dear bachcho, is a JEE Main PYQ. If something which cannot disproportionate over here, so here chlorine oxidation number +1, +3, +5, +7. If something is present in maximum oxidation state or minimum oxidation state, so from maximum going up not possible, minimum going down also not possible, disproportionation not possible. JEE Main PYQ, which cannot disproportionate, answer is ClO4-. Have a look at this reaction, very simple. All of them are redox. This is what? Combination. This is decomposition. This is displacement. And fourth one is what? Disproportionation. Have a look. NO2 +4. Here +3, +5. So +4 to +3, +4 to +5. Are you able to follow, everybody? Paradox of fractional oxidation number. Chala important, green box. Everybody, please remember these structures. Br along with individual oxidation numbers. Br3O8, tribromo octaoxide, has already been asked in NEET. These two are waiting to be asked. Tetrathionate and carbon suboxide. Remember name, remember formula. Carbon suboxide structure C3O2 along with individual oxidation number. So this is +2, this is +2, this is 0. Tetrathionate S4O6 2-. Tetrathionate S4O6 2-, everybody. This is tetrathionate. Okay, this is 0, 0, +5, +5. 0, 0, +5, +5. Please remember individual as well as average with structure. Then after that, this is a very important question. Very important. JEE Main 2025 asked. 2025 asked, waiting to appear in NEET if a difficulty level has to be increased. What is the difference between these two reactions? Difference between these two reactions is, everybody, Pb3O4 is 2PbO plus PbO2. Now PbO2 due to inert pair effect is a very good oxidizing agent. Now when Pb3O4 is reacting with HCl, basically two different reactions are happening. One is PbO plus HCl, which is an acid-base reaction, and other is PbO2, because Pb3O4 is 2PbO and 1 mole PbO2. Remember this also. So PbO2 is reacting. This is a redox reaction because chlorine -1 is getting oxidized to Cl2. And both reactions you will add. Both reactions you will add, you will get this. So question can come like this. This reaction is acid-base, redox, overall reaction. Overall reaction is acid-base, redox. It is a combination of both acid-base as well as redox reaction. But when same thing happens with HNO3, so HNO3 mein nitrogen is already in +5, further oxidation not possible. So HNO3 se beta PbO2 does not react. Chala important box beta, please make sure that you go through it nicely. So many questions can come from this, and if NEET has to increase their difficulty level, these are the things they will attack. So far it has not been done, but what has not happened in the past does not guarantee the future. NEET 2025 is the biggest example of that, right? So and this has been tested in JEE Mains. Okay, so go through this box, all the things I have explained to you, everything we have done over here. Okay, what is the difference with HNO3? HNO3 difference is that it is the passive nature of PbO2. PbO2 can react with HCl, but PbO2 cannot react with HNO3 because PbO2 is also an oxidizing agent, HNO3 is also an oxidizing agent. Then after this, we come to the balancing part. So balancing, we need not follow the typical ion electron method and all that. By shortcut, cross multiplication of n factors we can balance. So for example, let's take this reaction, everybody. Cr2O7 2- plus SO3 2- goes to Cr3 plus SO4 2-. Okay. So I got to balance this in the acidic medium. Let's have a look at it, everybody. So chromium over here, chromium over here is in +6. Chromium over here is in +6 and it is going to +3, right? +6 to +3, I have two chromiums. First we balance atoms undergoing change in oxidation number. N factor dichromate, I hope you remember, is 6. Sulfur is going from +4 to +6. One sulfur is there, N factor is 2. Okay, so N factor ratio 3:1, cross multiply. This will be 1, this will be 3. First balance atoms going change in oxidation number. This will be 1, this will be 3. And that's it. And sulfur 3, so balance sulfur 3. Now go for oxygen balancing. 3 3s are 9. And 9 and 7 is how much? 16. That is 3 4s are 12. So 4 less, 4 H2O. And 4 2s are 8. So I think 8 H plus will come over here. Let's go back and check the answer in NCERT, everyone. What is the answer? Yes, so this is the final answer. They have done it in 1000 steps, but we will do it like this. Okay, we unnecessarily, no need for ion, electron and all. Acha, if there was basic medium, so acidic medium, one example done. If there was basic medium, boys and girls, what would you do? After this H plus step, I hope you know, you will add equal number of OH minus. Suppose same question was basic medium. So add 8 OH minus here and add 8 OH minus here. And this 8 H plus and 8 OH minus will become 8 water. 8 water, 4 water, cancel it, you will get 4 water over here, right? So like this you can do the balancing, and that is all in redox. That is all in redox. Just practice few questions for balancing. And remember these indicators. So KMNO4 self indicator. For dichromate we use diphenylamine. For iodine we use sodium thiosulfate. Iodine we use sodium thiosulfate. Then after this few questions I have underlined for you in the exercises. So just practice them. This 7.14, last question I am discussing for today. This is a JEE main PYQ recently asked. Reaction of iodine with thiosulfate is extremely important. Please remember it. Iodine is, I told you na, Br2 and iodine. Br2 is a more powerful oxidizing agent. This is also present in exemplar if I am not wrong. Okay. So thiosulfate with iodine, remember this reaction forms tetrathionate. But thiosulfate with bromine, because bromine is more powerful, thiosulfate is going to tetrathionate. Change in oxidation number, everybody, is +2 to +2.5 with iodine. But thiosulfate with bromine is forming sulfate. Change in oxidation, and same will be with chlorine also. +2 to +6. So if I am correct, the question was that what does it prove about I2 and Br2? This proves that Br2 is a more powerful oxidizing agent than I2. This one I have already explained you, perzenic acid example. Then you can definitely practice some of the questions on balancing. And this one also you can try, because this involves both balancing as well as stoichiometry. All right. So that will be all for today. I think 5 chapters we did. 1 equilibrium is left, that most probably we'll complete tomorrow morning. So now Pan sir will come. He'll take over the session. Let's welcome him with a huge round of applause. Welcome, sir.
Sir, applause is not coming up.
So I will make that applause.
Break unko de do, sir.
So you'll get a 10 minutes of break, and after that sir will resume the classes.
10:38 you have to be back.
Okay, everybody. Bye bye. Take care. Sir will see you soon. I am going.